1910.1001, Asbestos. 1910.1001, A. Scope and application. 1910.1001, A.1. This section applies to all occupational exposures to asbestos in all industries covered by the Occupational Safety and Health Act, except as provided in paragraph A, 2, and 3 of this section. 1910.1001, A.2. This section does not apply to construction work as defined in 29 CFR 1910.12, B. Exposure to asbestos in construction work is covered by 29 CFR 1926.1101. 1910.1001, A.3. This section does not apply to ship repairing, shipbuilding and shipbreaking employments and related employments as defined in 29 CFR 1915.4. Exposure to asbestos in these employments is covered by 29 CFR 1915.1001. 1910.1001, B. Definitions. Asbestos includes chrysotile, amosite, crocidolite, tremolite asbestos, anthophyllite asbestos, actinolite asbestos, and any of these minerals that have been chemically treated and/or altered. Asbestos-containing material, ACM, means any material containing more than 1% asbestos. Assistant Secretary means the Assistant Secretary of Labor for Occupational Safety and Health, U.S. Department of Labor, or designee. Authorized person means any person authorized by the employer and required by work duties to be present in regulated areas. Building/facility owner is the legal entity, including a lessee, which exercises control over management and record-keeping functions relating to a building and/or facility in which activities covered by this standard take place. Certified Industrial Hygienist, CIH, means one certified in the practice of industrial hygiene by the American Board of Industrial Hygiene. Director means the Director of the National Institute for Occupational Safety and Health, U.S. Department of Health and Human Services, or designee. Employee exposure means that exposure to airborne asbestos that would occur if the employee were not using respiratory protective equipment. Fiber means a particulate form of asbestos 5 micrometers or longer, with a length-to-diameter ratio of at least 3:1. High-efficiency particulate air (HEPA) filter means a filter capable of trapping and retaining at least 99.97% of 0.3 micrometer diameter monodispersed particles. Homogeneous area means an area of surfacing material or thermal system insulation that is uniform in color and texture. Industrial hygienist means a professional qualified by education, training, and experience to anticipate, recognize, evaluate and develop controls for occupational health hazards. PACM means presumed asbestos containing material. Presumed asbestos containing material means thermal system insulation and surfacing material found in buildings constructed no later than 1980. The designation of a material as PACM may be rebutted pursuant to paragraph J8 of this section. Regulated area means an area established by the employer to demarcate areas where airborne concentrations of asbestos exceed, or there is a reasonable possibility they may exceed, the permissible exposure limits. Surfacing ACM means surfacing material which contains more than 1% asbestos. Surfacing material means material that is sprayed, troweled on or otherwise applied to surfaces, such as acoustical plaster on ceilings and fireproofing materials on structural members, or other materials on surfaces for acoustical, fireproofing, and other purposes. Thermal system insulation, TSI, means ACM applied to pipes, fittings, boilers, bridging, tanks, ducts or other structural components to prevent heat loss or gain. Thermal system insulation ACM means thermal system insulation which contains more than 1% asbestos. 1910.1001, C. Permissible exposure limit, PELS, 1910.1001, C. 1, V. Time-weighted average limit, TWA. The employer shall ensure that no employee is exposed to an airborne concentration of asbestos in excess of 0.1 fiber per cubic centimeter of air as an 8-hour time-weighted average, TWA, as determined by the method prescribed in Appendix A to this section, or by an equivalent method. 1910.1001, C. 2. Excursion limit. The employer shall ensure that no employee is exposed to an airborne concentration of asbestos in excess of 1.0 fiber per cubic centimeter of air, 1 F/cc, as averaged over a sampling period of 30 minutes as determined by the method prescribed in Appendix A to this section, or by an equivalent method. 1910.1001 d. Exposure monitoring. 1910.1001 d1. General. 1910.1001 d1 I. Determinations of employee exposure shall be made from breathing zone air samples that are representative of the 8-hour TWA and 30-minute short-term exposures of each employee. 1910.1001 d1 2. Representative 8-hour TWA employee exposures shall be determined on the basis of one or more samples representing full shift exposures for each shift for each employee in each job classification in each work area. Representative 30-minute short-term employee exposures shall be determined on the basis of one or more samples representing 30-minute exposures associated with operations that are most likely to produce exposures above the excursion limit for each shift for each job classification in each work area. 1910.1001 d2. Initial monitoring. 1910.1001 d2 I. Each employer who has a workplace or work operation covered by this standard, except as provided for in paragraphs D2(2) and D2(3) of this section, shall perform initial monitoring of employees who are, or may reasonably be expected to be exposed to airborne concentrations at or above the TWA permissible exposure limit and/or excursion limit. 1910.1001 D2(2), where the employer has monitored after March 31, 1992, for the TWA permissible exposure limit and/or the excursion limit, and the monitoring satisfies all other requirements of this section, the employer may rely on such earlier monitoring results to satisfy the requirements of paragraph D2(I) of this section. 1910.1001 D2(3), where the employer has relied upon objective data that demonstrate that asbestos is not capable of being released in airborne concentrations at or above the TWA permissible exposure limit and/or excursion limit under the expected conditions of processing, use, or handling, then no initial monitoring is required. 1910.1001 D3. Monitoring frequency, periodic monitoring, and patterns. After the initial determinations required by paragraph D2(I) of this section, samples shall be of such frequency and pattern as to represent with reasonable accuracy the levels of exposure of the employees. In no case shall sampling be at intervals greater than 6 months for employees whose exposures may reasonably be foreseen to exceed the TWA permissible exposure limit and/or excursion limit. 1910.1001 D4. Changes in monitoring frequency. If either the initial or the periodic monitoring required by paragraphs D2 and D3 of this section statistically indicates that employee exposures are below the TWA permissible exposure limit and/or excursion limit, the employer may discontinue the monitoring for those employees whose exposures are represented by such monitoring. 1910.1001 D5. Additional monitoring. Notwithstanding the provisions of paragraphs D2(2) and D4 of this section, the employer shall institute the exposure monitoring required under paragraphs D2(I) and D3 of this section whenever there has been a change in the production, process, control equipment, personnel or work practices that may result in new or additional exposures above the TWA permissible exposure limit and/or excursion limit, or when the employer has any reason to suspect that a change may result in new or additional exposures above the PL and/or excursion limit. 1910.1001 D6. Method of monitoring. 1910.1001 D6 I. All samples taken to satisfy the monitoring requirements of paragraph D of this section shall be personal samples collected following the procedures specified in Appendix A. 1910.1001 D6 2. All samples taken to satisfy the monitoring requirements of paragraph D of this section shall be evaluated using the OSHA reference method, ORM, specified in Appendix A of this section, or an equivalent counting method. 1910.1001 D6 3. If an equivalent method to the ORM is used, the employer shall ensure that the method meets the following criteria. 1910.1001 D6 3 A. through 1910.1001 D6, 3, C. Replicate exposure data used to establish equivalency are collected in side-by-side field and laboratory comparisons, and the comparison indicates that 90% of the samples collected in the range 0.5 to 2.0 times the permissible limit have an accuracy range of plus or minus 25% of the ORM results at a 95% confidence level as demonstrated by a statistically valid protocol, and the equivalent method is documented and the results of the comparison testing are maintained. 1910.1001 D6, 4. To satisfy the monitoring requirements of paragraph D of this section, employers must use the results of monitoring analysis performed by laboratories which have instituted quality assurance programs that include the elements as prescribed in Appendix A of this section. 1910.1001 D7. Employee notification of monitoring results. 1910.1001 D7 I. The employer must, within 15 working days after the receipt of the results of any monitoring performed under the sections, notify each affected employee of these results either individually in writing or by posting the results in an appropriate location that is accessible to affected employees. 1910.1001 D7, 2. The written notification required by paragraph D7 I of this section shall contain the corrective action being taken by the employer to reduce employee exposure to or below the TWA and/or excursion limit, wherever monitoring results indicated that the TWA and/or excursion limit had been exceeded. 1910.1001 E. Regulated areas. 1910.1001 E1 through 1910.1001 E5. Establishment. The employer shall establish regulated areas wherever airborne concentrations of asbestos and/or PCM are in excess of the TWA and/or excursion limit prescribed in paragraph C of this section. Demarcation. Regulated areas shall be demarcated from the rest of the workplace in any manner that minimizes the number of persons who will be exposed to asbestos. Access. Access to regulated areas shall be limited to authorized persons or to persons authorized by the Act or regulations issued pursuant thereto. Provision of respirators. Each person entering a regulated area shall be supplied with and required to use a respirator, selected in accordance with paragraph G2 of this section. Prohibited activities. The employer shall ensure that employees do not eat, drink, smoke, chew tobacco or gum, or apply cosmetics in the regulated areas. 1910.1001 F. Methods of compliance. 1910.1001 F1. Engineering controls and work practices. 1910.1001 F1 I. The employer shall institute engineering controls and work practices to reduce and maintain employee exposure to or below the TWA and/or excursion limit prescribed in paragraph C of this section, except to the extent that such controls are not feasible. 1910.1001 F1, 2. Wherever the feasible engineering controls and work practices that can be instituted are not sufficient to reduce employee exposure to or below the TWA and/or excursion limit prescribed in paragraph C of this section, the employer shall use them to reduce employee exposure to the lowest levels achievable by these controls and shall supplement them by the use of respiratory protection that complies with the requirements of paragraph G of this section. 1910.1001 F1, 3. For the following operations, wherever feasible engineering controls and work practices that can be instituted are not sufficient to reduce the employee exposure to or below the TWA and/or excursion limit prescribed in paragraph C of this section, the employer shall use them to reduce employee exposure to or below 0.5 fiber per cubic centimeter of air, as an 8-hour time-weighted average, or 2.5 fibers/cc for 30 minutes, short-term exposure, and shall supplement them by the use of any combination of respiratory protection that complies with the requirements of paragraph G of this section. Work practices and feasible engineering controls that will reduce employee exposure to or below the TWA and to or below the excursion limit permissible prescribed in paragraph C of this section. Coupling cutoff in primary asbestos cement pipe manufacturing, sanding in primary and secondary asbestos cement sheet manufacturing, grinding in primary and secondary friction product manufacturing, carding and spinning in dry textile processes, and grinding and sanding in primary plastics manufacturing. 1910.1001 F1 F1.4. Local exhaust ventilation. Local exhaust ventilation and dust collection systems shall be designed, constructed, installed, and maintained in accordance with good practices such as those found in the American National Standard Fundamentals Governing the Design and Operation of Local Exhaust Systems, ANSI Z 9.2-1979. 1910.1001, F1V, Particular Tools. All hand-operated and power-operated tools which would produce or release fibers of asbestos, such as, but not limited to, saws, scorers, abrasive wheels, and drills, shall be provided with local exhaust ventilation systems which comply with paragraph F1.4 of this section. 1910.1001, F1.6, Wet Methods. Insofar as practicable, asbestos shall be handled, mixed, applied, removed, cut, scored, or otherwise worked in a wet state sufficient to prevent the emission of airborne fibers so as to expose employees to levels in excess of the TWA and/or excursion limit, prescribed in paragraph C of this section, unless the usefulness of the product would be diminished thereby. 1910.1001, F1.7, Reserved. 1910.1001, F1.8, Particular products and operations. No asbestos cement, mortar, coating, grout, plaster, or similar material containing asbestos shall be removed from bags, cartons, or other containers in which they are shipped, without being either wetted or enclosed, or ventilated so as to prevent effectively the release of airborne fibers. 1910.1001, F1.9, Compressed air. Compressed air shall not be used to remove asbestos or materials containing asbestos unless the compressed air is used in conjunction with a ventilation system which effectively captures the dust cloud created by the compressed air. 1910.1001, F1.X, Flooring. Sanding of asbestos-containing flooring material is prohibited. 1910.1001, F2, Compliance Program. 1910.1001, F2I, where the TWA and/or excursion limit is exceeded, the employer shall establish and implement a written program to reduce employee exposure to or below the TWA and to or below the excursion limit by means of engineering and work practice controls as required by paragraph F1 of this section, and by the use of respiratory protection where required or permitted under this section. 1910.1001, F2.2, Such programs shall be reviewed and updated as necessary to reflect significant changes in the status of the employer's compliance program. 1910.1001, F2.3, Written programs shall be submitted upon request for examination and copying to the Assistant Secretary, the Director, affected, employees, and designated employee representatives. 1910.1001, F2.4, The employer shall not use employee rotation as a means of compliance with the TWA and/or excursion limit. 1910.1001, F3, Specific compliance methods for brake and clutch repair. 1910.1001, F3I, Engineering controls and work practices for brake and clutch repair and service. During automotive brake and clutch inspection, disassembly, repair and assembly operations, the employer shall institute engineering controls and work practices to reduce employee exposure to materials containing asbestos using a negative pressure enclosure/HEPA vacuum system method or low pressure/wet cleaning method, which meets the detailed requirements set out in Appendix F to this section. The employer may also comply using an equivalent method which follows written procedures which the employer demonstrates can achieve results equivalent to Method A in Appendix F to this section. For facilities in which no more than 5 pair of brakes or 5 clutches are inspected, disassembled, repaired, or assembled per week, the method set forth in paragraph D of Appendix F to this section may be used. 1910.1001, F3.2, The employer may also comply by using an equivalent method which follows written procedures, which the employer demonstrates can achieve equivalent exposure reductions as do the two preferred methods. Such demonstration must include monitoring data conducted under workplace conditions closely resembling the process, type of asbestos containing materials, control method, work practices, and environmental conditions which the equivalent method will be used, or objective data, which document that under all reasonably foreseeable conditions of brake and clutch repair applications, the method results in exposures which are equivalent to the methods set out in Appendix F to this section. 1910.1001, G. Respiratory protection. 1910.1001 G1 General. For employees who use respirators required by this section, the employer must provide each employee an appropriate respirator that complies with the requirements of this paragraph. Respirators must be used during 1910.1001 G1 I through 1910.1001 G1 4 periods necessary to install or implement feasible engineering and work practice controls. Work operations, such as maintenance and repair activities, for which engineering and work practice controls are not feasible. Work operations for which feasible engineering and work practice controls are not yet sufficient to reduce employee exposure to or below the TWA and/or excursion limit. Emergencies. 1910.1001 G2 Respirator Program. 1910.1001 G2 I. The employer must implement a respiratory protection program in accordance with 29 CFR 134B through D, except D, 1, 3, and F through M, which covers each employee required by this section to use a respirator. 1910.1001 G2 2. Employers must provide an employee with a tight-fitting, powered air purifying respirator, PAPR, instead of a negative pressure respirator selected according to paragraph G3 of this standard when the employee chooses to use a PAPR and it provides adequate protection to the employee. 1910.1001 G2 3. No employee must be assigned to tasks requiring the use of respirators if, based on their most recent medical examination, the examining physician determines that the employee will be unable to function normally using a respirator, or that the safety or health of the employee or other employees will be impaired by the use of a respirator. Such employees must be assigned to another job or given the opportunity to transfer to a different position, the duties of which they can perform. If such a transfer position is available, the position must be with the same employer, in the same geographical area, and with the same seniority, status, and rate of pay the employee had just prior to such transfer. 1910.1001 G3 Respirator Selection. Employers must 1910.1001 G3 I select and provide to employees the appropriate respirators specified in paragraph D3 I-A of 29 CFR 1910.134. However, employers must not select or use filtering facepiece respirators for protection against asbestos fibers. 1910.1001 G3 2 provide HEPA filters for powered and non-powered air purifying respirators. 1910.1001 H protective work clothing and equipment. 1910.1001 H1 provision and use. If an employee is exposed to asbestos above the TWA and/or excursion limit, or where the possibility of eye irritation exists, the employer shall provide at no cost to the employee and ensure that the employee uses appropriate protective work clothing and equipment such as, but not limited to, 1910.1001 H1 I through 1910.1001 H1 3 coveralls or similar full-body work clothing, gloves, head coverings, and foot coverings, and face shields, vented goggles, or other appropriate protective equipment which complies with 1910.133 of this part. 1910.1001 H2 Removal and storage. 1910.1001 H2 I through 1910.1001 H2 4. The employer shall ensure that employees remove work clothing contaminated with asbestos only in change rooms provided in accordance with paragraph I-1 of this section. The employer shall ensure that no employee takes contaminated work clothing out of the change room, except those employees authorized to do so for the purpose of laundering, maintenance, or disposal. Contaminated work clothing shall be placed and stored in closed containers which prevent dispersion of the asbestos outside the container. The employer shall ensure that containers of contaminated protective devices or work clothing, which are to be taken out of change rooms or the workplace for cleaning, maintenance, or disposal, bear labels in accordance with paragraph J of this section. 1910.1001 H3 Cleaning and replacement. 1910.1001 H3 I through 1910.1001 H3 6 The employer shall clean, launder, repair, or replace protective clothing and equipment required by this paragraph to maintain their effectiveness. The employer shall provide clean protective clothing and equipment at least weekly to each affected employee. The employer shall prohibit the removal of asbestos from protective clothing and equipment by blowing or shaking. Laundering of contaminated clothing shall be done so as to prevent the release of airborne fibers of asbestos in excess of the permissible exposure limits prescribed in paragraph C of this section. Any employer who gives contaminated clothing to another person for laundering shall inform such person of the requirement in paragraph H3(3) of this section to effectively prevent the release of airborne fibers of asbestos in excess of the permissible exposure limits. The employer shall inform any person who launders or cleans protective clothing or equipment contaminated with asbestos of the potentially harmful effects of exposure to asbestos. The employer shall ensure that contaminated clothing is transported in sealed impermeable bags or other closed, impermeable containers and labeled in accordance with paragraph J of this section. 1910.1001 I. Hygiene facilities and practices. 1910.1001 I-1. Change rooms. 1910.1001 I-1 I. The employer shall provide clean change rooms for employees who work in areas where their airborne exposure to asbestos is above the TWA and/or excursion limit. 1910.1001 I-1-2. The employer shall ensure that change rooms are in accordance with 1910.141 E of this part, and are equipped with 2 separate lockers or storage facilities, so separated as to prevent contamination of the employee's street clothes from his protective work clothing and equipment. 1910.1001 I-2. Showers. 1910.1001 I-2 I through 1910.1001 I-2-3. The employer shall ensure that employees who work in areas where their airborne exposure is above the TWA and/or excursion limit shower at the end of the work shift. 1910.1001 I-2-2. The employer shall provide shower facilities which comply with 1910.141 D-3 of this part. 1910.1001 I-2-3. The employer shall ensure that employees who are required to shower pursuant to paragraph I-2 of this section do not leave the workplace wearing any clothing or equipment worn during the work shift. 1910.1001 I-3. Lunchrooms. 1910.1001 I-3 I. The employer shall provide lunchroom facilities for employees who work in areas where their airborne exposure is above the TWA and/or excursion limit. 1910.1001 I-3-2. The employer shall ensure that lunchroom facilities have a positive pressure, filtered air supply, and are readily accessible to employees. 1910.1001 I-3-3. The employer shall ensure that employees who work in areas where their airborne exposure is above the PL and/or excursion limit wash their hands and faces prior to eating, drinking, or smoking. 1910.1001 I-3-4. The employer shall ensure that employees do not enter lunchroom facilities with protective work clothing or equipment unless surface asbestos fibers have been removed from the clothing or equipment by vacuuming or other method that removes dust without causing the asbestos to become airborne. 1910.1001 I-4. Smoking in work areas. The employer shall ensure that employees do not smoke in work areas where they are occupationally exposed to asbestos because of activities in that work area. 1910.1001 J. Communication of hazards to employees. Introduction. This section applies to the communication of information concerning asbestos hazards in general industry to facilitate compliance with this standard. Asbestos exposure in general industry occurs in a wide variety of industrial and commercial settings. Employees who manufacture asbestos-containing products may be exposed to asbestos fibers. Employees who repair and replace automotive brakes and clutches may be exposed to asbestos fibers. In addition, employees engaged in housekeeping activities in industrial facilities with asbestos product manufacturing operations, and in public and commercial buildings with installed asbestos-containing materials may be exposed to asbestos fibers. Most of these workers are covered by this general industry standard, with the exception of state or local governmental employees in non-state plan states. It should be noted that employees who perform housekeeping activities during and after construction activities are covered by the Asbestos Construction Standard, 29 CFR 1926.1101, formerly 1926.58. However, housekeeping employees, regardless of industry designation, should know whether building components they maintain may expose them to asbestos. The same hazard communication provisions will protect employees who perform housekeeping operations in all three asbestos standards: general industry, construction, and shipyard employment. As noted in the construction standard, building owners are often the only and/or best source of information concerning the presence of previously installed asbestos containing building materials. Therefore, they, along with employers of potentially exposed employees, are assigned specific information conveying and retention duties under this section. 1910.1001, J1, Hazard Communication, General. 1910.1001, J1, I, through 1910.1001, J1, 3, Chemical manufacturers, importers, distributors and employers shall comply with all requirements of the Hazard Communication Standard, HCS, Section 1910.1200, for asbestos. In classifying the hazards of asbestos, at least the following hazards are to be addressed: cancer and lung effects. Employers shall include asbestos in the hazard communication program established to comply with the HCS, Section 1910.1200. Employers shall ensure that each employee has access to labels on containers of asbestos and to safety data sheets, and is trained in accordance with the requirements of HCS in paragraph J7 of this section. 1910.1001, J2, Installed asbestos containing material. Employers and building owners are required to treat installed TSI and sprayed-on and troweled-on surfacing materials as ACM in buildings constructed no later than 1980 for purposes of this standard. These materials are designated presumed ACM or PACM, and are defined in paragraph B of this section. Asphalt and vinyl flooring material installed no later than 1980 also must be treated as asbestos-containing. The employer or building owner may demonstrate that PCM and flooring material do not contain asbestos by complying with paragraph J8(3) of this section. 1910.1001, J3, Duties of employers and building and facility owners. 1910.1001, J3I, Building and facility owners shall determine the presence, location, and quantity of ACM and/or PACM at the work site. Employers and building and facility owners shall exercise due diligence in complying with these requirements to inform employers and employees about the presence and location of ACM and PACM. 1910.1001, J3(2), Building and facility owners shall maintain records of all information required to be provided pursuant to this section and or otherwise known to the building owner concerning the presence, location, and quantity of ACM and PACM in the building/facility. Such records shall be kept for the duration of ownership and shall be transferred to successive owners. 1910.1001, J3(3), Building and facility owners shall inform employers of employees, and employers shall inform employees who will perform housekeeping activities in areas which contain ACM and or PACM of the presence and location of ACM and or PACM in such areas which may be contacted during such activities. 1910.1001, J4, Warning signs. 1910.1001, J4I, Posting. Warning signs shall be provided and displayed at each regulated area. In addition, warning signs shall be posted at all approaches to regulated areas so that an employee may read the signs and take necessary protective steps before entering the area. 1910.1001, J4(2), Sign Specifications. 1910.1001, J4(2)A. The warning signs required by paragraph J4I of this section shall bear the following legend: Danger. Asbestos may cause cancer. Causes damage to lungs. Authorized personnel only. 1910.1001, J4(2)B. In addition, where the use of respirators and protective clothing is required in the regulated area under this section, the warning signs shall include the following: wear respiratory protection and protective clothing in this area. 1910.1001, J4(2)C. Prior to June 1, 2016, employers may use the following legend in lieu of that specified in paragraph J4, 2a of this section. Danger. Asbestos. Cancer and lung disease. Hazard. Authorized personnel only. 1910.1001, J4, 2d. Prior to June 1, 2016, employers may use the following legend in lieu of that specified in paragraph J4, 2b of this section. Respirators and protective clothing are required in this area. 1910.1001, J4, 3. The employer shall ensure that employees working in and contiguous to regulated areas comprehend the warning signs required to be posted by paragraph J4I of this section. Means to ensure employee comprehension may include the use of foreign languages, pictographs, and graphics. 1910.1001, J4, 4. At the entrance to mechanical rooms/areas in which employees reasonably can be expected to enter and which contain ACM and/or PCM, the building owner shall post signs which identify the material which is present, its location, and appropriate work practices which, if followed, will ensure that ACM and/or PCM will not be disturbed. The employer shall ensure, to the extent feasible, that employees who come in contact with these signs can comprehend them. Means to ensure employee comprehension may include the use of foreign languages, pictographs, graphics, and awareness training. 1910.1001, J5. Warning labels. 1910.1001, J5I. Labeling. Labels shall be affixed to all raw materials, mixtures, scrap, waste, debris, and other products containing asbestos fibers, or to their containers. When a building owner or employer identifies previously installed ACM and/or PCM, labels or signs shall be affixed or posted so that employees will be notified of what materials contain ACM and/or PCM. The employer shall attach such labels in areas where they will clearly be noticed by employees who are likely to be exposed, such as at the entrance to mechanical room/areas. Signs required by paragraph J of this section may be posted in lieu of labels so long as they contain the information required for labeling. 1910.1001, J5, 2. Label specifications. In addition to the requirements of paragraph J1, the employer shall ensure that labels of bags or containers of protective clothing and equipment, scrap, waste, and debris containing asbestos fibers include the following information. Danger. Contains asbestos fibers. May cause cancer. Causes damage to lungs. Do not breathe dust. Avoid creating dust. 1910.1001, J5, 3. Prior to June 1, 2015, employers may include the following information on raw materials, mixtures, or labels of bags or containers of protective clothing and equipment, scrap, waste, and debris containing asbestos fibers in lieu of the labeling requirements in paragraphs J1I and J5(2) of this section. Danger. Contains asbestos fibers. Avoid creating dust. Cancer and lung disease hazard. 1910.1001, J6. The provisions for labels and for safety data sheets required by paragraph J of this section do not apply where 1910.1001, J6I. Asbestos fibers have been modified by a bonding agent, coating, binder, or other material provided that the manufacturer can demonstrate that during any reasonably foreseeable use, handling, storage, disposal, processing, or transportation, no airborne concentrations of fibers of asbestos in excess of the TWA permissible exposure level and/or excursion limit will be released or 1910.1001, J6, 2. Asbestos is present in a product in concentrations less than 1%. 1910.1001, J7. Employee information and training. 1910.1001, J7I through 1910.1001, J7, 3. The employer shall train each employee who is exposed to airborne concentrations of asbestos at or above the PL and/or excursion limit in accordance with the requirements of this section. The employer shall institute a training program and ensure employee participation in the program. Training shall be provided prior to or at the time of initial assignment and at least annually thereafter. The training program shall be conducted in a manner which the employee is able to understand. The employer shall ensure that each employee is informed of the following: 1910.1001, J7, 3a through 1910.1001, J7, 3j, the health effects associated with asbestos exposure, the relationship between smoking and exposure to asbestos producing lung cancer, The quantity, location, manner of use, release, and storage of asbestos, and the specific nature of operations which could result in exposure to asbestos. The engineering controls and work practices associated with the employee's job assignment. The specific procedures implemented to protect employees from exposure to asbestos, such as appropriate work practices, emergency and cleanup procedures, and personal protective equipment to be used. The purpose, proper use, and limitations of respirators and protective clothing, if appropriate. The purpose and a description of the medical surveillance program required by paragraph L of this section. The content of this standard, including appendices. The names, addresses, and phone numbers of public health organizations which provide information, materials, and/or conduct programs concerning smoking cessation. The employer may distribute the list of such organizations contained in Appendix I to this section to comply with this requirement. The requirements for posting signs and affixing labels and the meaning of the required legends for such signs and labels. 1910.1001, J7, 4. The employer shall also provide, at no cost to employees who perform housekeeping operations in an area which contains ACM or PCM, an asbestos awareness training course, which shall at a minimum contain the following elements: health effects of asbestos, locations of ACM and PCM in the building/facility, recognition of ACM and PCM damage and deterioration, requirements in this standard relating to housekeeping, and proper response to fiber release episodes, to all employees who perform housekeeping work in areas where ACM and/or PCM is present. Each such employee shall be so trained at least once a year. 1910.1001, J7, V. Access to information and training materials. 1910.1001, J7, V. A. through 1910.1001, J7, V. C. The employer shall make a copy of this standard and its appendices readily available without cost to all affected employees. The employer shall provide, upon request, all materials relating to the Employee Information and Training Program to the Assistant Secretary and the Training Program to the Assistant Secretary and the Director. The employer shall inform all employees concerning the availability of self-help smoking cessation program material. Upon employee request, the employer shall distribute such material, consisting of NIH publication No. 89 to 1647, or equivalent self-help material, which is approved or published by a public health organization listed in Appendix I to this section. 1910.1001, J7, 4. The employer shall also provide, at no cost to employees who perform housekeeping operations in an area which contains ACM or PCM, an asbestos awareness training course, which shall at a minimum contain the following elements: health effects of asbestos, locations of ACM and PCM in the building/facility, recognition of ACM and PCM damage and deterioration, requirements in this standard relating to housekeeping, and proper response to fiber release episodes. To all employees who perform housekeeping work in areas where ACM and/or PCM is present. Each such employee shall be so trained at least once a year. 1910.1001, J7, V. Access to information and training materials. 1910.1001, J7, V. A. through 1910.1001, J7, V. C. The employer shall make a copy of this standard and its appendices readily available without cost to all affected employees. The employer shall provide, upon request, all materials relating to the Employee Information and Training Program to the Assistant Secretary and the Training Program to the Assistant Secretary and the Director. The employer shall inform all employees concerning the availability of self-help smoking cessation program material. Upon employee request, the employer shall distribute such material, consisting of NIH publication No. 89 to 1647, or equivalent self-help material, which is approved or published by a public health organization listed in Appendix I to this section. 1910.1001, J8. Criteria to rebut the designation of installed material as PACM. 1910.1001, J8I. At any time, an employer and/or building owner may demonstrate, for purposes of this standard, that PCM does not contain asbestos. Building owners and/or employers are not required to communicate information about the presence of building material for which such a demonstration pursuant to the requirements of paragraph J8(2) of this section has been made. However,
In all such cases, the information, data, and analysis supporting the determination that PACM does not contain asbestos shall be retained pursuant to paragraph M of this section. 1910.1001 J. 8.2. An employer or owner may demonstrate that PACM does not contain asbestos by the following. 1910.1001 J. 8.2a.
Having a completed inspection conducted pursuant to the requirements of AHERA 40 CFR 763, subpart E, which demonstrates that no ACM is present in the material, or
1910.1001 J. 8.2b. Performing tests of the material containing PACM which demonstrate that no ACM is present in the material.
Such tests shall include analysis of bulk samples collected in the manner described in 40 CFR 763.86. The tests, evaluation, and sample collection shall be conducted by an accredited inspector or by a CIH. Analysis of samples shall be performed by persons or laboratories with proficiency demonstrated by current successful participation in a nationally recognized testing program such as the National Voluntary Laboratory Accreditation Program, NVLAP, or the National Institute for Standards and Technology, NIST, or the round robin for bulk samples administered by the American Industrial Hygiene Association, AIHA, or an equivalent nationally recognized round robin testing program.
1910.1001 J. 8.3. The employer and/or building owner may demonstrate that flooring material, including associated mastic and backing, does not contain asbestos by a determination of an industrial hygienist based upon recognized analytical techniques showing that the material is not ACM. 1910.1001 K. Housekeeping. 1910.1001 K.1. All surfaces shall be maintained as free as practicable of ACM waste and debris and accompanying dust. 1910.1001 K.2. All spills and sudden releases of material containing asbestos shall be cleaned up as soon as possible. 1910.1001 K.3. Surfaces contaminated with asbestos may not be cleaned by the use of compressed air. 1910.1001 K.4. Vacuuming. HEPA-filtered vacuuming equipment shall be used for vacuuming asbestos containing waste and debris. The equipment shall be used and emptied in a manner which minimizes the re-entry of asbestos into the workplace. 1910.1001 K.5. Shoveling, dry sweeping, and dry cleanup of asbestos may be used only where vacuuming and/or wet cleaning are not feasible. 1910.1001 K.6. Waste disposal. Waste, scrap, debris, bags, containers, equipment, and clothing contaminated with asbestos consigned for disposal shall be collected, recycled, and disposed of in sealed impermeable bags or other closed, impermeable containers. 1910.1001 K.7. Care of asbestos-containing flooring material. 1910.1001 K.7 I through 1910.1001 K.7 3. Sanding of asbestos-containing floor material is prohibited. Stripping of finishes shall be conducted using low abrasion pads at speeds lower than 300 rpm and wet methods. Burnishing or dry buffing may be performed only on asbestos-containing flooring which has sufficient finish so that the pad cannot contact the asbestos-containing material. 1910.1001 K.8. Waste and debris and accompanying dust in an area containing accessible ACM and/or PACM or visibly deteriorated ACM shall not be dusted or swept dry or vacuumed without using a HEPA filter. 1910.1001 L. Medical surveillance. 1910.1001 L1. General. 1910.1001 L1 I. Employees covered. The employer shall institute a medical surveillance program for all employees who are or will be exposed to airborne concentrations of fibers of asbestos at or above the TWA and/or excursion limit. 1910.1001 L1-2. Examination by a physician. 1910.1001 L1-2a. The employer shall ensure that all medical examinations and procedures are performed by or under the supervision of a licensed physician, and shall be provided without cost to the employee and at a reasonable time and place. 1910.1001 L1-2b. Persons other than licensed physicians, who administer the pulmonary function testing required by this section, shall complete a training course in spirometry sponsored by an appropriate academic or professional institution. 1910.1001 L2 Pre-placement examinations. 1910.1001 L2 I. Before an employee is assigned to an occupation exposed to airborne concentrations of asbestos fibers at or above the TWA and/or excursion limit, a pre-placement medical examination shall be provided or made available by the employer. 1910.1001 L2 Such examination shall include,
as a minimum, a medical and work history, a complete physical examination of all systems with emphasis on the respiratory system, the cardiovascular system and digestive tract, completion of the respiratory disease standardized questionnaire in Appendix D to this section, Part 1, a 14 by 17-inch or other reasonably sized standard film or digital posterior anterior chest X-ray, pulmonary function tests to include forced vital capacity, FVC, and forced expiratory volume at 1 second, FEV1, and any additional tests deemed appropriate by the examining physician. Classification of all chest X-rays shall be conducted in accordance with Appendix E to this section. 1910.1001 L3 Periodic examinations. 1910.1001 L3 I. Periodic medical examinations shall be made available annually. 1910.1001 L3 2 The scope of the medical examination shall be in conformance with the protocol established in paragraph L2 of this section, except that the frequency of chest X-rays shall be conducted in accordance with Table 1 to this section, and the abbreviated standardized questionnaire contained in Part 2 of Appendix D to this section shall be administered to the employee. For 0 to 10 years since first exposure, X-rays should occur every 5 years for every age group. For 10+ years since first exposure, ages 15 to 35 should get an X-ray every 5 years. Ages 35 to 45 should get an X-ray every 2 years. For ages 45 and older should get an X-ray every year. 1910.1001 L4 Termination of employment examinations. 1910.1001 L4 I. The employer shall provide, or make available, a termination of employment medical examination for any employee who has been exposed to airborne concentrations of fibers of asbestos at or above the TWA and/or excursion limit. 1910.1001 L4 2 The medical examination shall be in accordance with the requirements of the periodic examinations stipulated in paragraph L3 of this section, and shall be given within 30 calendar days before or after the date of termination of employment. 1910.1001 L5 Recent examinations. No medical examination is required of any employee if adequate records show that the employee has been examined in accordance with any of paragraphs L2 through L4 of this section within the past 1-year period. A pre-employment medical examination which was required as a condition of employment by the employer may not be used by that employer to meet the requirements of this paragraph, unless the cost of such examination is borne by the employer. 1910.1001 L6 Information provided to the physician. The employer shall provide the following information to the examining physician. 1910.1001 L6 I through 1910.1001 L6 V. A copy of this standard and Appendices D and E. A description of the affected employee's duties as they relate to the employee's exposure. The employee's representative exposure level or anticipated exposure level. A description of any personal protective and respiratory equipment used or to be used. Information from previous medical examinations of the affected employee that is not otherwise available to the examining physician. 1910.1001 L7 Physician's written opinion. 1910.1001 L7 I. The employer shall obtain a written opinion from the examining physician. This written opinion shall contain the results of the medical examination and shall include 1910.1001 L7 I.A. through 1910.1001 L7 I.D. The physician's opinion as to whether the employee has any detected medical conditions that would place the employee at an increased risk of material health impairment from exposure to asbestos, any recommended limitations on the employee or upon the use of personal protective equipment such as clothing or respirators. A statement that the employee has been informed by the physician of the results of the medical examination and of any medical conditions resulting from asbestos exposure that require further explanation or treatment. And a statement that the employee has been informed by the physician of the increased risk of lung cancer attributable to the combined effect of smoking and asbestos exposure. 1910.1001, L. 7, 2. The employer shall instruct the physician not to reveal in the written opinion given to the employer specific findings or diagnoses unrelated to occupational exposure to asbestos. 1910.1001, L. 7, 3. The employer shall provide a copy of the physician's written opinion to the affected employee within 30 days from its receipt. 1910.1001, M. Record keeping. 1910.1001, M1, Exposure measurements. Note, the employer may utilize the services of competent organizations such as industry trade associations and employee associations to maintain the records required by this section. 1910.1001, M1, I. The employer shall keep an accurate record of all measurements taken to monitor employee exposure to asbestos as prescribed in paragraph D of this section. 1910.1001, M1, 2. This record shall include at least the following information. 1910.1001, M1, 2, A, through 1910.1001, M1, 2, F, the date of measurement. The operation involving exposure to asbestos which is being monitored. Sampling and analytical methods used in evidence of their accuracy. Number, duration, and results of samples taken. Type of respiratory protective devices worn, if any. And name and exposure of the employees whose exposure are represented. 1910.1001, M1, 3. The employer shall maintain this record for at least 30 years, in accordance with 29 CFR 1910.20. 1910.1001, M. Record keeping. 1910.1001, M1, Exposure measurements. Note, the employer may utilize the services of competent organizations such as industry trade associations and employee associations to maintain the records required by this section. 1910.1001, M1, I. The employer shall keep an accurate record of all measurements taken to monitor employee exposure to asbestos as prescribed in paragraph D of this section. 1910.1001, M1, 2. This record shall include at least the following information. 1910.1001, M1, 2, A, through 1910.1001, M1, 2, F, the date of measurement. The operation involving exposure to asbestos which is being monitored. Sampling and analytical methods used in evidence of their accuracy. Number, duration, and results of samples taken. Type of respiratory protective devices worn, if any. And name and exposure of the employees whose exposure are represented. 1910.1001, M1, 3. The employer shall maintain this record for at least 30 years, in accordance with 29 CFR 1910.20. 1910.1001, M3, Medical surveillance. 1910.1001, M3, I. The employer shall establish and maintain an accurate record for each employee subject to medical surveillance by paragraph L1I of this section, in accordance with 29 CFR 1910.1020. 1910.1001, M3, 2. The record shall include at least the following information. 1910.1001, M3, 2, A, through 1910.1001, M3, 2, D. The name of the employee. Physician's written opinions, any employee medical complaints related to exposure to asbestos, and a copy of the information provided to the physician as required by paragraph L6 of this section. 1910.1001, M3, 3. The employer shall ensure that this record is maintained for the duration of employment plus 30 years, in accordance with 29 CFR 1910.1020. 1910.1001, M4, Training. The employer shall maintain all employee training records for 1 year beyond the last date of employment of that employee. 1910.1001, M5,
Availability.
1910.1001 M5 I. The employer, upon written request, shall make all records required to be maintained by this section available to the Assistant Secretary and the Director for examination and copying.
1910.1001 M5 2.
The employer, upon request, shall make any exposure records required by paragraph M1 of this section available for examination and copying to affected employees, former employees, designated representatives, and the Assistant Secretary, in accordance with 29 CFR 1910.1020 A through E and G through I.
1910.1001 M5 3.
The employer, upon request, shall make employee medical records required by paragraph M3 of this section available for examination and copying to the subject employee, to anyone having the specific written consent of the subject employee, and the Assistant Secretary, in accordance with 29 CFR 1910.1020.
1910.1001 M6. Transfer of records. The employer shall comply with the requirements concerning transfer of records set forth in 29 CFR 1910.1020 H. 1910.1001 N. Observation of monitoring. 1910.1001 N1. Employee observation. The employer shall provide affected employees or their designated representatives an opportunity to observe any monitoring of employee exposure to asbestos conducted in accordance with paragraph D of this section. 1910.1001 N2. Observation procedures. When observation of the monitoring of employee exposure to asbestos requires entry into an area where the use of protective clothing or equipment is required, the observer shall be provided with and be required to use such clothing and equipment and shall comply with all other applicable safety and health procedures. 1910.1001 O. Appendices. 1910.1001 O1.
Appendices A, C, D, E, and F to this section are incorporated as part of this section, and the contents of these appendices are mandatory.
1910.1001 O2.
Appendices B, G, H, I, and J to this section are informational and are not intended to create any additional obligations not otherwise imposed or to detract from any existing obligations.
1910.1001 Appendix A. OSHA Reference Method. Mandatory. Appendix A to Section 1910.1001. OSHA Reference Method. Mandatory.
This mandatory appendix specifies the procedure for analyzing air samples for asbestos and specifies quality control procedures that must be implemented by laboratories performing the analysis. The sampling and analytical methods described below represent the elements of the available monitoring methods, such as Appendix B of this regulation, the most current version of the OSHA method ID 160, or the most current version of the NIOSH method 7400. All employers who are required to conduct air monitoring under paragraph F of the standard are required to utilize analytical laboratories that use this procedure, or an equivalent method, for collecting and analyzing samples. Sampling and analytical procedure. The sampling medium for air samples shall be mixed cellulose ester filter membranes. These shall be designated by the manufacturer as suitable for asbestos counting. See below for rejection of blanks. 2. The preferred collection device shall be the 25 mm diameter cassette with an open-faced 50 mm electrically conductive extension cowl. The 37 mm cassette may be used if necessary, but only if written justification for the need to use the 37 mm filter cassette accompanies the sample results in the employee's exposure monitoring record. Do not reuse or reload cassettes for asbestos sample collection. 3. An airflow rate between 0.5 liter/min and 2.5 liters/min shall be selected for the 25/mm cassette. If the 37 mm cassette is used, an airflow rate between 1 liter/min and 2.5 liters/min shall be selected. 4. Where possible, a sufficient air volume for each air sample shall be collected to yield between 100 and 1,300 fibers per square millimeter on the membrane filter. If a filter darkens in appearance or if loose dust is seen on the filter, a second sample shall be started. 5. Ship the samples in a rigid container with sufficient packing material to prevent dislodging the collected fibers. Packing material that has a high electrostatic charge on its surface, e.g., expanded polystyrene, cannot be used because such material can cause loss of fibers to the sides of the cassette. 6. Calibrate each personal sampling pump before and after use with a representative filter cassette installed between the pump and the calibration devices. 7. Personal samples shall be taken in the breathing zone of the employee, i.e., attached to or near the collar or lapel near the worker's face. 8. Fiber counts shall be made by positive phase contrast using a microscope with an 8 to 10 times eyepiece and a 40 to 45 times objective for a total magnification of approximately 400 times and a numerical aperture of 0.65 to 0.75. The microscope shall also be fitted with a green or blue filter. 9. The microscope shall be fitted with a Walton-Beckett eyepiece graticule calibrated for a field diameter of 100 micrometers, plus or minus 2 micrometers. 10. The phase shift detection limit of the microscope shall be about 3 degrees measured using the HSE phase shift test slide as outlined below. A. Place the test slide on the microscope stage and center it under the phase objective. B. Bring the blocks of groove lines into focus. Note, the slide consists of 7 sets of groove lines, ca. 20 grooves to each block, in descending order of visibility from sets 1 to 7, 7 being the least visible. The requirements for asbestos counting are that the microscope optics must resolve the groove lines in set 3 completely, although they may appear somewhat faint, and that the groove lines in sets 6 and 7 must be invisible. Sets 4 and 5 must be at least partially visible but may vary slightly in visibility between microscopes. A microscope that fails to meet these requirements has either too low or too high a resolution to be used for asbestos counting. C. If the image deteriorates, clean and adjust the microscope optics. If the problem persists, consult the microscope manufacturer. 11. Each set of samples taken will include 10% field blanks or a minimum of 2 field blanks. These blanks must come from the same lot as the filters used for sample collection. The field blank results shall be averaged and subtracted from the analytical results before reporting. A set consists of any sample or group of samples for which an evaluation for this standard must be made. Any samples represented by a field blank having a fiber count in excess of the detection limit of the method being used shall be rejected. 12. The sample shall be mounted by the acetone/triaceton method or a method with an equivalent index of refraction and similar clarity. 13. Observe the following counting rules. A. Count only fibers equal to or longer than 5 micrometers. Measure the length of curved fibers along the curve. B. In the absence of other information, count all particles as asbestos that have a length-to-width ratio, aspect ratio, of 3 to 1 or greater. C. Fibers lying entirely within the boundary of the Walton-Beckett graticule field shall receive a count of 1. Fibers crossing the boundary once, having one end within the circle, shall receive the count of 1/2, 1/2. Do not count any fiber that crosses the graticule boundary more than once. Reject and do not count any other fibers even though they may be visible outside the graticule area. D. Count bundles of fibers as one fiber unless individual fibers can be identified by observing both ends of an individual fiber. E. Count enough graticule fields to yield 100 fibers. Count a minimum of 20 fields, stop counting at 100 fields regardless of fiber count. 14. Blind recounts shall be conducted at the rate of 10%. Quality control procedures. 1. Intra-laboratory program. Each laboratory and/or each company with more than one microscopist counting slides shall establish a statistically designed quality assurance program involving blind recounts and comparisons between microscopists to monitor the variability of counting by each microscopist and between microscopists. In a company with more than one laboratory, the program shall include all laboratories and shall also evaluate the laboratory-to-laboratory variability. 2. An interlaboratory program. Each laboratory analyzing asbestos samples for compliance determination shall implement an interlaboratory quality assurance program that, as a minimum, includes participation of at least 2 other independent laboratories. Each laboratory shall participate in round-robin testing at least once every 6 months with at least all the other laboratories in its interlaboratory quality assurance group.
Each laboratory shall submit slides typical of its own workload for use in this program. The round robin shall be designed and results analyzed using appropriate statistical methodology. B. All laboratories should also participate in a national sample testing scheme such as the Proficiency Analytical Testing Program, PATI, or the Asbestos Registry sponsored by the American Industrial Hygiene Association, AIHA. 3. All individuals performing asbestos analysis must have taken the NIOSH course for sampling and evaluating airborne asbestos dust or an equivalent course. 4. When the use of different microscopes contributes to differences between counters and laboratories, the effect of the different microscope shall be evaluated and the microscope shall be replaced, as necessary. 5. Current results of these quality assurance programs shall be posted in each laboratory to keep the microscopists informed. 1910.1001 Appendix B. Detailed procedures for asbestos sampling and analysis. Non-mandatory. Matrix Air, OSHA permissible exposure limits. Time-weighted average is 0.1 fiber/cc. Excursion level, 30 minutes, is 1.0 fiber/cc. A known volume of air is drawn through a 25 mm diameter cassette containing a mixed cellulose ester filter. The cassette must be equipped with an electrically conductive 50 mm extension cowl. The sampling time and rate are chosen to give a fiber density of between 100 to 1,300 fibers/mm2 on the filter. Recommended sampling rate 0.5 to 5.0 liters/minute L/min. Recommended air volumes. Minimum is 25 L. Maximum is 400 L. Analytical procedure. A portion of the sample filter is cleared and prepared for asbestos fiber counting by phase contrast microscopy, PCM, at 400x. Commercial manufacturers and products mentioned in this method are for descriptive use only and do not constitute endorsements by OSHA. Similar products from other sources can be substituted. 1. Introduction. This method describes the collection of airborne asbestos fibers using calibrated sampling pumps with mixed cellulose ester, MC, filters and analysis by phase contrast microscopy, PCM. Some terms used are unique to this method and are defined below. Asbestos, a term for naturally occurring fibrous minerals. Asbestos includes chrysotile, crocidolite, amosite, cummingtonite, grunerite asbestos, tremolite asbestos, actinolite asbestos, anthophyllite asbestos, and any of these minerals that have been chemically treated and/or altered. The precise chemical formulation of each species will vary with the location from which it was mined. Nominal compositions are listed. Chrysotile, crocidolite, amosite, tremolite, actinolite, anthophyllite. Asbestos fiber, a fiber of asbestos which meets the criteria specified below for a fiber. Aspect ratio, the ratio of the length of a fiber to its diameter, e.g. 3:1, 5:1 aspect ratios. Cleavage fragments, mineral particles formed by comminution of minerals, especially those characterized by parallel sides and a moderate aspect ratio, usually less than 20:1. Detection limit, the number of fibers necessary to be 95% certain that the result is greater than 0. Differential counting, the term applied to the practice of excluding certain kinds of fibers from the fiber count because they do not appear to be asbestos. Fiber, a particle that is 5 or longer, with a length-to-width ratio of 3:1 or longer. Field, the area within the graticule circle that is superimposed on the microscope image. Set, the samples which are taken, submitted to the laboratory, analyzed, and for which interim or final result reports are generated. Tremolite, anthophyllite, and actinolite, the non-asbestos form of these minerals which meet the definition of a fiber. It includes any of these minerals that have been chemically treated and/or altered. Walton-Beckett graticule, an eyepiece graticule specifically designed for asbestos fiber counting. It consists of a circle with a projected diameter of 100 plus or minus 2 area of about 0.00785 mm, 2, with a crosshair having tick marks at 3 intervals in one direction and 5 in the orthogonal direction. There are marks around the periphery of the circle to demonstrate the proper sizes and shapes of fibers. His design is reproduced in Figure 1. The disc is placed in one of the microscope eyepieces so that the design is superimposed on the field of view.
1.1 History. Early surveys to determine asbestos exposures were conducted using Impingeur counts of total dust, with the counts expressed as million particles per cubic foot. The British Asbestos Research Council recommended filter membrane counting in 1969. In July 1969, the Bureau of Occupational Safety and Health published a filter membrane method for counting asbestos fibers in the United States. This method was refined by NIOSH and published as P and Chem 239. On May 29, 1971, OSHA specified filter membrane sampling with phase contrast counting for evaluation of asbestos exposures at work sites in the United States. The use of this technique was again required by OSHA in 1986. Phase contrast microscopy has continued to be the method of choice for the measurement of occupational exposure to asbestos. 1.2. Principle: air is drawn through a MCE filter to capture airborne asbestos fibers. A wedge-shaped portion of the filter is removed, placed on a glass microscope slide and made transparent. A measured area, field, is viewed by PCM. All the fibers meeting defined criteria for asbestos are counted and considered a measure of the airborne asbestos concentration. 1.3. Advantages and disadvantages. There are four main advantages of PCM over other methods. 1. The technique is specific for fibers. Phase contrast is a fiber counting technique which excludes non-fibrous particles from the analysis. 2. The technique is inexpensive and does not require specialized knowledge to carry out the analysis for total fiber counts. 3. The analysis is quick and can be performed on-site for rapid determination of air concentrations of asbestos fibers. 4. The technique has continuity with historical epidemiological studies so that estimates of expected disease can be inferred from long-term determinations of asbestos exposures. The main disadvantage of PCM is that it does not positively identify asbestos fibers. Other fibers which are not asbestos may be included in the count unless differential counting is performed. This requires a great deal of experience to adequately differentiate asbestos from non-asbestos fibers. Positive identification of asbestos must be performed by polarized light or electron microscopy techniques. A further disadvantage of PCM is that the smallest visible fibers are about 0.2 micrometers in diameter, while the finest asbestos fibers may be as small as 0.02 micrometers in diameter. For some exposures, substantially more fibers may be present than are actually counted. 1.4. Workplace exposure. Asbestos is used by the construction industry in such products as shingles, floor tiles, asbestos cement, roofing felts, insulation and acoustical products. Non-construction uses include brakes, clutch facings, paper, paints, plastics, and fabrics. One of the most significant exposures in the workplace is the removal and encapsulation of asbestos in schools, public buildings, and homes. Many workers have the potential to be exposed to asbestos during these operations. About 95% of the asbestos in commercial use in the United States is chrysotile. Crossatolite and amazite make up most of the remainder. Anthophthalite and tremolite or actinolite are likely to be encountered as contaminants in various industrial products. 1.5. Physical properties. Asbestos fiber possesses a high tensile strength along its axis, is chemically inert, non-combustible, and heat-resistant. It has a high electrical resistance and good sound-absorbing properties. It can be weaved into cables, fabrics or other textiles, and also matted into asbestos papers, felts, or mats. 2. Range and detection limit. 2.1. The ideal counting range on the filter is 100 to 1,300 fibers/m2. With a Walton-Beckett graticule, this range is equivalent to 0.8 to 10 fibers/field. Using NIOSH counting statistics, a count of 0.8 fibers/field would give an approximate coefficient of variation, CV, of 0.13. 2.2. The detection limit for this method is 4.0 fibers per 100 fields or 5.5 fibers/m2. This was determined using an equation to estimate the maximum CV possible at a specific concentration, 95% confidence, and a lower control limit of 0. The CV value was then used to determine a corresponding concentration from historical CV versus fiber relationships. As an example, Lower control limit, 95% confidence, equals AC, 1.645 CV, AC. Where? AC equals estimate of the airborne fiber concentration, fibers/cc, setting the lower control limit equals 0 and solving for CV. 0 equals AC, 1.645 CV, AC. CV equals 0.61. This value was compared with CV versus count curves. The count at which CV equals 0.61 for Lytle Bush counting statistics or for an OSHA Salt Lake Technical Center, OSHA SLTC, CV curve, see Appendix A for further information, was 4.4 fibers or 3.9 fibers per 100 fields, respectively. Although a lower detection limit of 4 fibers per 100 fields is supported by the OSHA SLTC data, both datasets support the 4.5 fibers per 100 fields value. 3. Method performance, precision and accuracy. Precision is dependent upon the total number of fibers counted and the uniformity of the fiber distribution on the filter. A general rule is to count at least 20 and not more than 100 fields. The count is discontinued when 100 fibers are counted, provided that 20 fields have already been counted. Counting more than 100 fibers results in only a small gain in precision. As the total count drops below 10 fibers, an accelerated loss of precision is noted. At this time, there is no known method to determine the absolute accuracy of the asbestos analysis. Results of samples prepared through the Proficiency Analytical Testing (PAT) program and analyzed by the OSHA SLTC showed no significant bias when compared to PAT reference values. The PAT samples were analyzed from 1987 to 1989, N equals 36, and the concentration range was from 120 to 1,300 fibers/m2. 4. Interferences. Fibrous substances, if present, may interfere with asbestos analysis. Some common fibers are fiberglass, anhydrite, plant fibers, perlite veins, gypsum, some synthetic fibers, membrane structures, sponge spicules, diatoms, microorganisms, wollastonite. The use of electron microscopy or optical tests such as polarized light and dispersion staining may be used to differentiate these materials from asbestos when necessary. 5. Sampling. 5.1. Equipment. 5.1.1. Sample assembly. The assembly is shown in Figure 3. Conductive filter holder consisting of a 25 mm diameter, 3-piece cassette having a 50 mm long electrically conductive extension cowl. Backup pad, 25 mm, cellulose. Membrane filter, mixed cellulose ester, MCE, 25 mm, plain, white, 0.4 to 1.2 micrometer pore size. Notes. A. Do not reuse cassettes. B. Fully conductive cassettes are required to reduce fiber loss to the sides of the cassette due to electrostatic attraction. C. Purchase filters which have been selected by the manufacturer for asbestos counting or analyze representative filters for fiber background before use. Discard the filter lot if more than 4 fibers/100 fields are found. D. To decrease the possibility of contamination, the sampling system, filter backup pad cassette, for asbestos is usually pre-assembled by the manufacturer. E. Other cassettes, such as the bell mouth, may be used within the limits of their validation. 5.1.2. Gel bands for sealing cassettes. 5.1.3. Sampling pump. Each pump must be a battery-operated, self-contained unit small enough to be placed on the monitored employee and not interfere with the work being performed. The pump must be capable of sampling at the collection rate for the required sampling time. 5.1.4. Flexible tubing, 6 mm bore. 5.1.5. Pump calibration. Stopwatch and bubble tube/burette or electronic meter. 5.2. Sampling procedure. 5.2.1. Seal the point where the base and cowl of each cassette meet with a gel band or tape. 5.2.2. Charge the pumps completely before beginning. 5.2.3. Connect each pump to a calibration cassette with an appropriate length of 6 mm bore plastic tubing. Do not use lure connectors. The type of cassette specified above has built-in adapters. 5.2.4. Select an appropriate flow rate for the situation being monitored. The sampling flow rate must be between 0.5 and 5.0 liters per minute for personal sampling and is commonly set between 1 and 2 liters per minute. Always choose a flow rate that will not produce overloaded filters. 5.2.5. Calibrate each sampling pump before and after sampling with a calibration cassette inline. Note, this calibration cassette should be from the same lot of cassettes used for sampling. Use a primary standard, e.g., bubble burette, to calibrate each pump. If possible, calibrate at the sampling site. Note, if sampling site calibration is not possible, environmental influences may affect the flow rate. The extent is dependent on the type of pump used. Consult with the pump manufacturer to determine dependence on environmental influences. If the pump is affected by temperature and pressure changes, correct the flow rate using the formula shown in the section Sampling Pump Flow Rate Corrections at the end of this appendix. 5.2.6. Connect each pump to the base of each sampling cassette with flexible tubing. Remove the end cap of each cassette and take each air sample open face. Assure that each sample cassette is held open side down in the employee's breathing zone during sampling. The distance from the nose/mouth of the employee to the cassette should be about 10 centimeters. Secure the cassette on the collar or lapel of the employee using spring clips or other similar devices. 5.2.7. A suggested minimum air volume when sampling to determine TWA compliance is 25 liters. For excursion limit, 30 minutes sampling time, evaluations, a minimum air volume of 48 liters is recommended. 5.2.8. The most significant problem when sampling for asbestos is overloading the filter with non-asbestos dust. Suggested maximum air sample volumes for specific environments are: asbestos removal operations, visible dust, 100. Asbestos removal operations, little dust, 240. Office environments 400 to 2400. Caution: do not overload the filter with dust. High levels of non-fibrous dust particles may obscure fibers on the filter and lower the count or make counting impossible. If more than about 25 to 30% of the field area is obscured with dust, the result may be biased low. Smaller air volumes may be necessary when there is excessive non-asbestos dust in the air. While sampling, observe the filter with a small flashlight. If there is a visible layer of dust on the filter, stop sampling, remove and seal the cassette, and replace with a new sampling assembly. The total dust loading should not exceed 1 mg. 5.2.9. Blank samples are used to determine if any contamination has occurred during sample handling. Prepare 2 blanks for the first 1 to 20 samples. For sets containing greater than 20 samples, prepare blanks as 10% of the samples. Handle blank samples in the same manner as air samples with one exception: do not draw any air through the blank samples. Open the blank cassette in the place where the sample cassettes are mounted on the employee. Hold it open for about 30 seconds. Close and seal the cassette appropriately. Store blanks for shipment with the sample cassettes. May 2, 2010. Immediately after sampling, close and seal each cassette with the base and plastic plugs. Do not touch or puncture the filter membrane as this will invalidate the analysis. May 2, 2011. Attach and secure a sample seal around each sample cassette in such a way as to assure that the end cap and base plugs cannot be removed without destroying the seal. Tape the ends of the seal together since the seal is not long enough to be wrapped end to end. Also wrap tape around the cassette at each joint to keep the seal secure. 5.3. Sample shipment. 5.3.1. Send the samples to the laboratory with paperwork requesting asbestos analysis. List any known fibrous interferences present during sampling on the paperwork. Also, note the workplace operations sampled. 5.3.2. Secure and handle the samples in such that they will not rattle during shipment nor be exposed to static electricity. Do not ship samples in expanded polystyrene peanuts, vermiculite, paper shreds, or Excelsior. Tape sample cassettes to sheet bubbles and place in a container that will cushion the samples in such a manner that they will not rattle. 5.3.3. To avoid the possibility of sample contamination, always ship bulk samples in separate mailing containers. 6. Analysis. 6.1. Safety precautions. 6.1.1. Acetone is extremely flammable and precautions must be taken not to ignite it. Avoid using large containers or quantities of acetone. Transfer the solvent in a ventilated laboratory hood. Do not use acetone near any open flame. For generation of acetone vapor, use a spark-free heat source. 6.1.2. Any asbestos spills should be cleaned up immediately to prevent dispersal of fibers. Prudence should be exercised to avoid contamination of laboratory facilities or exposure of personnel to asbestos. Asbestos spills should be cleaned up with wet methods and / or a high-efficiency particulate air, HEPA, filtered vacuum. Caution: do not use a vacuum without a HEPA filter, it will disperse fine asbestos fibers in the air. 6.2. Equipment. 6.2.1. Phase contrast microscope with binocular or trinocular head. 6.2.2. Wide field or Hygenian 10x eyepieces. Note: the eyepiece containing the graticule must be a focusing eyepiece. Use a 40x phase objective with a numerical aperture of 0.65 to 0.75. 6.2.3. Kohler illumination, if possible, with green or blue filter. 6.2.4. Walton Beckett graticule, type G22 with 100 plus or minus 2 micrometers projected diameter. 6.2.5. Mechanical stage. A rotating mechanical stage is convenient for use with polarized light. 6.2.6. Phase telescope. 6.2.7. Stage micrometer with 0.01 mm subdivisions.
6.2.8. Phase shift test slide, Mark II, available from PTR Optics Limited, and also Macron. 6.2.9. Pre-cleaned glass slides, 25 mm x 75 mm.
One end can be frosted for convenience in writing sample numbers, etc., or paste on labels can be used.
June 2nd, 10. Cover glass number 1 1/2. June 2nd, 11. Scalpel, number 10, curved blade. June 2nd, 12. Fine-tipped forceps. June 2nd, 13. Aluminum block for clearing filter, see Appendix D and Figure 4. June 2nd, 14. Automatic adjustable pipette, 100 to 500 ul. June 2nd, 15. Micropipette, 5 ul. 6.3. Reagent, S. 6.3.1. Acetone, HPLC grade. 6.3.2. Triacetin, glycerol triacetate. 6.3.3. Lacquer or nail polish. 6.4. Standard preparation. A way to prepare standard asbestos samples of known concentration has not been developed. It is possible to prepare replicate samples of nearly equal concentration. This has been performed through the PAT program. These asbestos samples are distributed by the AIHA to participating laboratories. Since only about 1/4 of a 25 mm sample membrane is required for an asbestos count, any PAT sample can serve as a standard for replicate counting. 6.5. Sample mounting. Note: see safety precautions in section 6.1. Before proceeding, the objective is to produce samples with a smooth, non-grainy background in a medium with a refractive index of approximately 1.46. The technique below collapses the filter for easier focusing and produces permanent mounts which are useful for quality control and interlaboratory comparison. An aluminum block or similar device is required for sample preparation. 6.5.1. Heat the aluminum block to about 70 degrees Celsius. The hot block should not be used on any surface that can be damaged by either the heat or from exposure to acetone. 6.5.2. Ensure that the glass slides and cover glasses are free of dust and fibers. 6.5.3. Remove the top plug to prevent a vacuum when the cassette is opened. Clean the outside of the cassette if necessary. Cut the seal and/or tape on the cassette with a razor blade. Very carefully separate the base from the extension cowl, leaving the filter and backup pad in the base. 6.5.4. With a rocking motion, cut a triangular wedge from the filter using the scalpel. This wedge should be 1/6 to 1/4 of the filter. Grasp the filter wedge with the forceps on the perimeter of the filter, which was clamped between the cassette pieces. Do not touch the filter with your finger. Place the filter on the glass slide sample side up. Static electricity will usually keep the filter on the slide until it is cleared. 6.5.5. Place the tip of the micropipette containing about 200 L acetone into the aluminum block. Insert the glass slide into the receiving slot in the aluminum block. Inject the acetone into the block with slow, steady pressure on the plunger while holding the pipette firmly in place. Wait 3 to 5 seconds for the filter to clear, then remove the pipette and slide from the aluminum block. 6.5.6. Immediately, less than 30 seconds, place 2.5 to 3.5 L of triacetone on the filter. Note, waiting longer than 30 seconds will result in increased index of refraction and decreased contrast between the fibers and the preparation. This may also lead to separation of the cover slip from the slide. 6.5.7. Lower a cover slip gently onto the filter at a slight angle to reduce the possibility of forming air bubbles. If more than 30 seconds have elapsed between acetone exposure and triacetone application, glue the edges of the cover slip to the slide with lacquer or nail polish. 6.5.8. If clearing is slow, warm the slide for 15 minutes on a hot plate having a surface temperature of about 50 degrees Celsius to hasten clearing. The top of the hot block can be used if the slide is not heated too long. 6.5.9. Counting may proceed immediately after clearing and mounting are completed. 6.6.1. Alignment. 1. Clean all optical surfaces. Even a small amount of dirt can significantly degrade the image. 2. Rough focus the objective on a sample. 3. Close down the field iris so that it is visible in the field of view. Focus the image of the iris with the condenser focus. Center the image of the iris in the field of view. 4. Install the phase telescope and focus on the phase rings. Critically center the rings. Misalignment of the rings results in astigmatism, which will degrade the image. 5. Place the phase shift test slide on the microscope stage and focus on the lines. The analyst must see line set 3 and should see at least parts of 4 and 5 but not see line set 6 or 6. A microscope/microscopist combination which does not pass this test may not be used. 6.6.2. Counting fibers. 1. Place the prepared sample slide on the mechanical stage of the microscope. Position the center of the wedge under the objective lens and focus upon the sample. 2. Start counting from one end of the wedge and progress along a radial line to the other end. Count in either direction from perimeter to wedge tip. Select fields randomly, without looking into the eyepieces, by slightly advancing the slide in one direction with the mechanical stage control. 3. Continually scan over a range of focal planes, generally the upper 10 to 15 of the filter surface, with the fine focus control during each field count. Spend at least 5 to 15 seconds per field. 4. Most samples will contain asbestos fibers with fiber diameters less than 1 Look carefully for faint fiber images. The small diameter fibers will be very hard to see. However, they are an important contribution to the total count. 5. Count only fibers equal to or longer than 5 Measure the length of curved fibers along the curve. 6. Count fibers which have a length to width ratio of 3 to 1 or greater. 7. Count all the fibers in at least 20 fields. Continue counting until either 100 fibers are counted or 100 fields have been viewed, whichever occurs first. count all the fibers in the final field.
8. Fibers lying entirely within the boundary of the Walton-Beckett graticule field shall receive a count of 1. Fibers crossing the boundary once, having one end within the circle, shall receive a count of 1/2. Do not count any fiber that crosses the graticule boundary more than once. Reject and do not count any other fibers even though they may be visible outside the graticule area. If a fiber touches the circle, it is considered to cross the line. 9. Count bundles of fibers as one fiber unless individual fibers can be clearly identified and each individual fiber is clearly not connected to another counted fiber. See Figure 1 for counting conventions. 10. Record the number of fibers in each field in a consistent way such that filter non-uniformity can be assessed.
11. Regularly check phase ring alignment.
12. When an agglomerate mass of material covers more than 25% of the field of view, reject the field and select another.
Do not include it in the number of fields counted. 13. Perform a blind recount of 1 in every 10 filter wedges, slides.
Relabel the slides using a person other than the original counter.
6.7. Fiber identification. As previously mentioned in Section 1.3, PCM does not provide positive confirmation of asbestos fibers. Alternate differential counting techniques should be used if discrimination is desirable.
Differential counting may include primary discrimination based on morphology, polarized light analysis of fibers, or modification of PCM data by scanning electron or transmission electron microscopy. A great deal of experience is required to routinely and correctly perform differential counting. It is discouraged unless it is legally necessary. Then, only if a fiber is obviously not asbestos should it be excluded from the count. Further discussion of this technique can be found in reference 8.10. If there is a question whether a fiber is asbestos or not, follow the rule. When in doubt, count. 6.8. Analytical Recommendations Quality Control System. 6.8.1. All individuals performing asbestos analysis must have taken the NIOSH course for sampling and evaluating airborne asbestos or an equivalent course. 6.8.2. Each laboratory engaged in asbestos counting shall set up a slide trading arrangement with at least 2 other laboratories in order to compare performance and eliminate inbreeding of error. The slide exchange occurs at least semi-annually. The round-robin results shall be posted where all analysts can view individual analysts' results. 6.8.3. Each laboratory engaged in asbestos counting shall participate in the Proficiency Analytical Testing Program, the Asbestos Analyst Registry or equivalent. 6.8.4. Each analyst shall select and count prepared slides from a slide bank. These are quality assurance counts. The slide bank shall be prepared using uniformly distributed samples taken from the workload. Fiber densities should cover the entire range routinely analyzed by the laboratory. These slides are counted blind by all counters to establish an original standard deviation. This historical distribution is compared with the quality assurance counts. A counter must have 95% of all quality control samples counted within 3 standard deviations of the historical mean. This count is then integrated into a new historical mean and standard deviation for the slide. The analyses done by the counters to establish the slide bank may be used for an interim quality control program if the data are treated in a proper statistical fashion. 7.1. Calculate the estimated airborne asbestos fiber concentration on the filter sample using the following formula, where AC equals airborne fiber concentration, FB equals total number of fibers greater than 5 uncounted, FL equals total number of fields counted on the filter, BFB equals total number of fibers greater than 5 uncounted in the blank, BFL equals total number of fields counted on the blank, ECA equals effective collecting area of filter, 385 mm, 2, nominal for a 25 mm filter. FR equals pump flow rate, L/min, MFA equals microscope count field area, mm, 2. This is 0.00785 mm, 2, for a Walton-Beckett graticule. T equals sample collection time, min, 1000 equals conversion of L to cc. Note, the collection area of a filter is seldom equal to 385 mm, 2. It is appropriate for laboratories to routinely monitor the exact diameter using an inside micrometer. The collection area is calculated according to Toth formula. Area equals pi d/2 2. 7.2. Shortcut calculation. Since a given analyst always has the same interpupillary distance, the number of fields per filter for a particular analyst will remain constant for a given size filter. The field size for that analyst is constant, i.e., the analyst is using an assigned microscope and is not changing the reticle. For example, if the exposed area of the filter is always 385 mm, 2, and the size of the field is always 0.00785 mm, 2, the number of fields per filter will always be 49,000. In addition, it is necessary to convert liters of air to cc. These three constants can then be combined such that ECA/1000 x MFA equals 49. The previous equation simplifies to 7.3. Recount calculations. As mentioned in Step 13 of Section 6.6.2, a blind recount of 10% of the slides is performed. In all cases, differences will be observed between the first and second counts of the same filter wedge. Most of these differences will be due to chance alone, that is, due to the random variability, precision, of the count method. Statistical recount criteria enables one to decide whether observed differences can be explained due to chance alone or are probably due to systematic differences between analysts, microscopes, or other biasing factors. The following recount criterion is for a pair of counts that estimate AC in fibers/cc. The criterion is given at the type I error level. That is, there is 5% maximum risk that we will reject a pair of counts for the reason that one might be biased, when the large observed difference is really due to chance. Reject a pair of counts if, where, AC 1 equals lower estimated airborne fiber concentration, AC 2 equals higher estimated airborne fiber concentration, AC average equals average of the two concentration estimates, CV, FB equals CV for the average of the two concentration estimates. If a pair of counts are rejected by this criterion, then recount the rest of the filters in the submitted set. Apply the test and reject any other pairs failing the test. Rejection shall include a memo to the industrial hygienist stating that the sample failed a statistical test for homogeneity and the true air concentration may be significantly different than the reported value. 7.4. Reporting results. Report results to the industrial hygienist as fibers/cc. Use two significant figures. If multiple analyses are performed on a sample, an average of the results is to be reported unless any of the results can be rejected for cause. 8. References. 8.1. Dreesen, W. C. et al., U.S. Public Health Service, A Study of Asbestosis in the Asbestos Textile Industry, Public Health Bulletin No. 241, U.S. Treasury Department, Washington, D.C., 1938. 8.2. Asbestos Research Council, The Measurement of Airborne Asbestos Dust by the Membrane Filter Method. Technical Note, Asbestos Research Council, Rochdale, Lancashire, Great Britain, 1969. 8.3. Bayer, S.G., Zumwalt, R.D., Brown, T.A. Equipment and Procedure for Mounting Millipore Filters and Counting Asbestos Fibers by Phase Contrast Microscopy, Bureau of Occupational Health, U.S. Department of Health, Education, and Welfare, Cincinnati, Ohio, 1969. 8.4. NIOSH Manual of Analytical Methods, 2nd edition, Volume 1, DHEW/NIOSH Pub. No. 77-157A. National Institute for Occupational Safety and Health, Cincinnati, Ohio, 1977. Pages 239 to 239 to 21. 8.5. Asbestos, Code of Federal Regulations, 29 CFR 1910.1001. 1971. 8.6. Occupational exposure to asbestos, tremolite, anthophyllite, and actinolite. Final Rule, Federal Register 51:119, June 20, 1986. Pages 22,612 to 22,790. 8.7. Asbestos, tremolite, anthophyllite, and actinolite, Code of Federal Regulations 1910.1001.
1988, pages 711 to 752. 8.8 Criteria for a recommended standard occupational exposure to asbestos, DHEW/NIOSH Pub. No. HSM 72 to 10267, National Institute for Occupational Safety and Health, NIOSH, Cincinnati, Ohio, 1972. Pages 3-13-24. 8.9 Ladel, N.A. Bayer, S.J. Zumwalt, R.D. Bush, K.A. USPHS/NIOSH membrane filter method for evaluating airborne asbestos fibers, DHEW/NIOSH Pub. No. 79 to 127, National Institute for Occupational Safety and Health, Cincinnati, Ohio, 1979. 8.10 Dixon, W.C. Applications of Optical Microscopy in Analysis of Asbestos and Quartz, Analytical Techniques in Occupational Health Chemistry, edited by D.D. Dahlberg and A.W. Verstueft. Washington. DAC American Chemical Society, ACS Symposium Series 120, 1980. Pages 13 to 41. Quality Control. The OSHA asbestos regulations require each laboratory to establish a quality control program. The following is presented as an example of how the OSHA SLTC constructed its internal CV curve as part of meeting this requirement. Data is from 395 samples collected during OSHA compliance inspections and analyzed from October 1980 through April 1986. Each sample was counted by 2 to 5 different counters independently of one another. The standard deviation and the CV statistic was calculated for each sample. This data was then plotted on a graph of CV versus fibers/mm2. A least squares regression was performed using the following equation. CV equals antilog 10 a log 10 x 2 plus b log 10 x plus c, where x equals the number of fibers/mm2. Application of least squares gave a equals 0.182205, b equals 0.973343, c equals 0.327499. Using these values, the equation becomes CV equals antilog 10 0.182205 log 10 x 2 0.973343 log 10 x plus 0.327499. Sampling pump flow rate corrections. This correction is used if a difference greater than 5% in ambient temperature and/or pressure is noted between calibration and sampling sites and the pump does not compensate for the differences. Where Q act equals actual flow rate. Q cal equals calibrated flow rate. If a rotometer was used, the rotometer value P cal equals uncorrected air pressure at calibration. P act equals uncorrected air pressure at sampling site. T act equals temperature at sampling site. K T cal equals temperature at calibration. K Walton-Beckett graticule. When ordering the graticule for asbestos counting, specify the exact disc diameter needed to fit the ocular of the microscope and the diameter, m, of the circular counting area. Instructions for measuring the dimensions necessary are listed. 1. Insert any available graticule into the focusing eyepiece and focus so that the graticule lines are sharp and clear. 2. Align the microscope. 3. Place a stage micrometer on the microscope object stage and focus the microscope on the graduated lines. 4. Measure the magnified grid length, PL, using the stage micrometer. 5. Remove the graticule from the microscope and measure its actual grid length, AL, This can be accomplished by using a mechanical stage fitted with verniers, or a jeweler's loupe with a direct reading scale. 6. Let D equals 100 Calculate the circle diameter, DEC, for the Walton-Beckett graticule and specify the diameter when making a purchase. 7. Each eyepiece objective reticle combination on the microscope must be calibrated. Should any of the three be changed, by zoom adjustment, disassembly, replacement, etc., the combination must be recalibrated. Calibration may change if interpupillary distance is changed. Measure the field diameter, D, acceptable range, 100 plus or minus 2 with a stage micrometer upon receipt of the graticule from the manufacturer. Determine the field area, 2. Field area equals pi, d/2, 2. If d equals 100 equals 0.1 millimeters, then field area equals pi, 0.1 mm/2, 2, equals 0.00785 mm, 2. The graticule is available from Graticules Limited, Morley Road, Tunbridge TN9 IRN, Kent, England, telephone 011-44-732-3596061. Also available from PTR Optics Limited, 145, Newton Street, Waltham, Massachusetts, 02154, telephone 617-891-6000, or Macron Accessories and Components, 2506S. Michigan Avenue, Chicago, Illinois, 60616, phone 312-842-7100. The graticule is custom made for each microscope. Figure 1 Walton Beckett graticule with some explanatory fibers. Structure number 1 to 6, the count is 1, small fibers all contained within the circle. Structure number 7, the count is half, fiber crosses circle once. Structure number 8, the count is 0, fiber 2 short. Structure number 9, the count is 2, 2 crossing fibers. Structure number 10, the count is 0, fiber outside graticule. Structure number 11, the count is 0, fiber crosses graticule twice. Structure number 12, the count is half, although split, fiber only crosses once. 1910.1001 Appendix C, reserved. 1910.1101 Appendix D, medical questionnaires, mandatory. This mandatory appendix contains the medical questionnaires that must be administered to all employees who are exposed to asbestos above permissible exposure limit, and who will therefore be included in their employer's medical surveillance program. Part 1 of this appendix contains the medical questionnaire, which must be administered to all employees who are provided periodic medical examinations under the medical surveillance provisions of the standard in this section. 1910.1001 Appendix E, classification of chest X-rays, mandatory. A. Chest X-rays shall be classified in accordance with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011, incorporated by reference, see section 1926.6, and recorded on a classification form following the format of the CDC/NIOSH M 2.8 form. As a minimum, the content within the bold lines of this form, items 1 through 4, shall be included. This form is not to be submitted to NIOSH. B. All X-rays shall be classified only by a beer reader, a board-eligible/certified radiologist, or an experienced physician with known expertise in pneumoconioses. C. Whenever classifying chest X-ray film, the physician shall have immediately available for reference a complete set of the ILO standard format radiographs provided for use with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011. D. Whenever classifying digitally acquired chest X-rays, the physician shall have immediately available for reference a complete set of ILO standard digital chest radiographic images provided for use with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011. Classification of digitally acquired chest X-rays shall be based on the viewing of images displayed as electronic copies and shall not be based on the viewing of hard copy printed transparencies of images. 1910.1001 Appendix F, Work Practices in Engineering Controls for Automotive Brake and Clutch Inspection, Disassembly, Repair and Assembly, mandatory. Appendix F to Section 1910.1001, Work Practices in Engineering Controls for Automotive Brake and Clutch Inspection, Disassembly, Repair and Assembly, mandatory. This mandatory appendix specifies engineering controls and work practices that must be implemented by the employer during automotive brake and clutch inspection, disassembly, repair, and assembly operations. Proper use of these engineering controls and work practices by trained employees will reduce employees' asbestos exposure below the permissible exposure level during clutch and brake inspection, disassembly, repair, and assembly operations. The employer shall institute engineering controls and work practices using either the method set forth in paragraph A or paragraph B of this appendix, or any other method which the employer can demonstrate to be equivalent in terms of reducing employee exposure to asbestos as defined and which meets the requirements described in paragraph C of this appendix,
for those facilities in which no more than 5 pairs of brakes or 5 clutches are inspected, disassembled, reassembled, and/or repaired per week, the method set forth in paragraph D of this appendix may be used. A. Negative pressure enclosure/HEPA vacuum system method.
1. The brake and clutch inspection, disassembly, repair, and assembly operations shall be enclosed to cover and contain the clutch or brake assembly and to prevent the release of asbestos fibers into the worker's breathing zone.
2. The enclosure shall be sealed tightly and thoroughly inspected for leaks before work begins on brake and clutch inspection, disassembly, repair, and assembly. 3. The enclosure shall be such that the worker can clearly see the operation and shall provide impermeable sleeves through which the worker can handle the brake and clutch inspection, disassembly, repair, and assembly. The integrity of the sleeves and ports shall be examined before work begins. 4. A HEPA-filtered vacuum shall be employed to maintain the enclosure under negative pressure throughout the operation.
Compressed air may be used to remove asbestos fibers or particles from the enclosure.
5. The HEPA vacuum shall be used first to loosen the asbestos-containing residue from the brake and clutch parts and then to evacuate the loosened asbestos-containing material from the enclosure and capture the material in the vacuum filter. 6. The vacuum's filter, when full, shall be first wetted with a fine mist of water, then removed and placed immediately in an impermeable container, labeled according to paragraph J5 of this section and disposed of according to paragraph K of this section.
7.
Any spills or releases of asbestos containing waste material from inside of the enclosure or vacuum hose or vacuum filter shall be immediately cleaned up and disposed of according to paragraph K of this section. B. Low pressure/wet cleaning method.
1.
A catch basin shall be placed under the brake assembly, positioned to avoid splashes and spills. 2. The reservoir shall contain water containing an organic solvent or wetting agent. The flow of liquid shall be controlled such that the brake assembly is gently flooded to prevent the asbestos-containing brake dust from becoming airborne. 3. The aqueous solution shall be allowed to flow between the brake drum and brake support before the drum is removed. 4. After removing the brake drum, the wheel hub and back of the brake assembly shall be thoroughly wetted to suppress dust. 5. The brake support plate, brake shoes and brake components used to attach the brake shoes shall be thoroughly washed before removing the old shoes. 6. In systems using filters, the filters, when full, shall be first wetted with a fine mist of water, then removed and placed immediately in an impermeable container, labeled according to paragraph J4 of this section and disposed of according to paragraph K of this section. 7. Any spills of asbestos-containing aqueous solution or any asbestos-containing waste material shall be cleaned up immediately and disposed of according to paragraph K of this section. 8. The use of dry brushing during low-pressure/wet cleaning operations is prohibited. C. Equivalent methods. An equivalent method is one which has sufficient written detail so that it can be reproduced and has been demonstrated that the exposures resulting from the equivalent method are equal to or less than the exposures which would result from the use of the method described in paragraph A of this appendix. For purposes of making this comparison, the employer shall assume that exposures resulting from the use of the method described in paragraph A of this appendix shall not exceed 0.016 f/cc, as measured by the OSHA reference method and is averaged over at least 18 personal samples. D. Wet method. 1. A spray bottle, hose nozzle, or other implement capable of delivering a fine mist of water or amended water or other delivery system capable of delivering water at low pressure, shall be used to first thoroughly wet the brake and clutch parts. Brake and clutch components shall then be wiped clean with a cloth. 2. The cloth shall be placed in an impermeable container, labeled according to paragraph J4 of this section and then disposed of according to paragraph K of this section, or the cloth shall be laundered in a way to prevent the release of asbestos fibers in excess of 0.1 fiber per cubic centimeter of air. 3. Any spills of solvent or any asbestos-containing waste material shall be cleaned up immediately according to paragraph K of this section. 4. The use of dry brushing during the wet method operations is prohibited. 1910.1001 Appendix G. Substance Technical Information for Asbestos. Non-mandatory. Appendix G to Section 1910.1001 Substance Technical Information for Asbestos. Non-mandatory. I. Substance identification. A. Substance.
Asbestos is the name of a class of magnesium silicate minerals that occur in fibrous form. Minerals that are included in this group are chrysotile, crocidolite, amosite, tremolite asbestos, anthophyllite asbestos, and actinolite asbestos. B. Asbestos is used in the manufacture of heat-resistant clothing, automotive brake and clutch linings, and a variety of building materials including floor tiles, roofing felts, ceiling tiles, asbestos cement pipe and sheet, and fire-resistant drywall. Asbestos is also present in pipe and boiler insulation materials, and in sprayed-on materials located on beams, in crawlspaces, and between walls. C. The potential for a product containing asbestos to release breathable fibers depends on its degree of friability. Friable means that the material can be crumbled with hand pressure and is therefore likely to emit fibers. The fibrous or fluffy sprayed-on materials used for fireproofing, insulation, or soundproofing are considered to be friable, and they readily release airborne fibers if disturbed. Materials such as vinyl asbestos floor tile or roofing felts are considered non-friable and generally do not emit airborne fibers unless subjected to sanding or sawing operations. Asbestos cement pipe or sheet can emit airborne fibers if the materials are cut or sawed, or if they are broken during demolition operations. D. Permissible exposure. Exposure to airborne asbestos fibers may not exceed 0.2 fibers per cubic centimeter of air, 0.1 f/cc, averaged over the 8-hour workday. 2. Health hazard data. A. Asbestos can cause disabling respiratory disease and various types of cancers if the fibers are inhaled. Inhaling or ingesting fibers from contaminated clothing or skin can also result in these diseases. The symptoms of these diseases generally do not appear for 20 or more years after initial exposure. B. Exposure to asbestos has been shown to cause lung cancer, mesothelioma, and cancer of the stomach and colon. Mesothelioma is a rare cancer of the thin membrane lining of the chest and abdomen. Symptoms of mesothelioma include shortness of breath, pain in the walls of the chest, and/or abdominal pain. 3. Respirators and protective clothing. A. Respirators. You are required to wear a respirator when performing tasks that result in asbestos exposure that exceeds the permissible exposure limit, PL, of 0.1 f/cc. These conditions can occur while your employer is in the process of installing engineering controls to reduce asbestos exposure, or where engineering controls are not feasible to reduce asbestos exposure. Air purifying respirators equipped with a high-efficiency particulate air (HEPA) filter can be used where airborne asbestos fiber concentrations do not exceed 2 f/cc. Otherwise, air-supplied, positive pressure, full face-piece respirators must be used. Disposable respirators or dust masks are not permitted to be used for asbestos work. For effective protection, respirators must fit your face and head snugly. Your employer is required to conduct fit tests when you are first assigned a respirator and every 6 months thereafter. Respirators should not be loosened or removed in work situations where their use is required. B. Protective clothing. You are required to wear protective clothing in work areas where asbestos fiber concentrations exceed the permissible exposure limit. 4. Disposal procedures and cleanup. A. Wastes that are generated by processes where asbestos is present include 1. Empty asbestos shipping containers. 2. Process waste such as cuttings, trimmings, or reject material. 3. Housekeeping waste from sweeping or vacuuming. 4. Asbestos fireproofing or insulating material that is removed from buildings. 5. Building products that contain asbestos removed during building renovation or demolition. 6. Contaminated disposable protective clothing. B. Empty shipping bags can be flattened under exhaust hoods and packed into airtight containers for disposal. Empty shipping drums are difficult to clean and should be sealed. C. Vacuum bags or disposable paper filters should not be cleaned, but should be sprayed with a fine water mist and placed into a labeled waste container. D. Process waste and housekeeping waste should be wetted with water or a mixture of water and surfactant prior to packaging in disposable containers. E. Material containing asbestos that is removed from buildings must be disposed of in leak-tight 6 mm thick plastic bags, plastic-lined cardboard containers, or plastic-lined metal containers.
These wastes, which are removed while wet, should be sealed in containers before they dry out to minimize the release of asbestos fibers during handling.
V. Access to information. A.
Each year, your employer is required to inform you of the information contained in this standard and appendices for asbestos. In addition, your employer must instruct you in the proper work practices for handling materials containing asbestos and the correct use of protective equipment.
B. Your employer is required to determine whether you are being exposed to asbestos.
You or your representative has the right to observe employee measurements and to record the results obtained. Your employer is required to inform you of your exposure, and, if you are exposed above the permissible limit, he or she is required to inform you of the actions that are being taken to reduce your exposure to within the permissible limit.
C.
Your employer is required to keep records of your exposures and medical examinations.
These exposure records must be kept for at least 30 years. Medical records must be kept for the period of your employment plus 30 years. D.
Your employer is required to release your exposure and medical records to your physician or designated representative upon your written request.
1910.1001 Appendix H. Medical Surveillance Guidelines for Asbestos. Non-mandatory.
Appendices Section 1910.1001 Medical Surveillance Guidelines for Asbestos. Non-mandatory.
I. Route of entry. Inhalation, ingestion. 2. Toxicology.
Clinical evidence of the adverse effects associated with exposure to asbestos is present in the form of several well-conducted epidemiological studies of occupationally exposed workers, family contacts of workers, and persons living near asbestos mines. These studies have shown a definite association between exposure to asbestos and an increased incidence of lung cancer, pleural and peritoneal mesothelioma, gastrointestinal cancer, and asbestosis. The latter is a disabling fibrotic lung disease that is caused only by exposure to asbestos. Exposure to asbestos has also been associated with an increased incidence of esophageal, kidney, laryngeal, pharyngeal, and buccal cavity cancers. As with other known chronic occupational diseases, disease associated with asbestos generally appears about 20 years following the first occurrence of exposure.
There are no known acute effects associated with exposure to asbestos.
Epidemiological studies indicate that the risk of lung cancer among exposed workers who smoke cigarettes is greatly increased over the risk of lung cancer among non-exposed smokers or exposed non-smokers. These studies suggest that cessation of smoking will reduce the risk of lung cancer for a person exposed to asbestos but will not reduce it to the same level of risk as that existing for an exposed worker who has never smoked.
3. Signs and symptoms of exposure-related disease.
The signs and symptoms of lung cancer or gastrointestinal cancer induced by exposure to asbestos are not unique, except that a chest X-ray of an exposed patient with lung cancer may show pleural plaques, pleural calcification, or pleural fibrosis, and may also show asbestosis, i.e., small irregular parenchymal opacities. Symptoms characteristic of mesothelioma include shortness of breath, pain in the chest, or abdominal pain. Mesothelioma has a much longer average latency period compared with lung cancer, 40 years versus 15 to 20 years, and mesothelioma is therefore more likely to be found among workers who were first exposed to asbestos at an early age.
Mesothelioma is a fatal disease. Asbestosis is pulmonary fibrosis caused by the accumulation of asbestos fibers in the lungs.
Symptoms include shortness of breath, coughing, fatigue, and vague feelings of sickness. When the fibrosis worsens, shortness of breath occurs even at rest. The diagnosis of asbestosis is most commonly based on a history of exposure to asbestos, the presence of characteristic radiologic abnormalities, and inspiratory crackles, rales, and other clinical features of fibrosing lung disease. Pleural plaques and thickening may be observed on chest X-rays. Asbestosis is often a progressive disease even in the absence of continued exposure, although this appears to be a highly individualized characteristic. In severe cases, death may be caused by respiratory or cardiac failure.
4. Surveillance and preventive considerations.
As noted above, exposure to asbestos has been linked to an increased risk of lung cancer, mesothelioma, gastrointestinal cancer, and asbestosis among occupationally exposed workers. Adequate screening tests to determine an employee's potential for developing serious chronic diseases, such as a cancer, from exposure to asbestos do not presently exist. However, some tests, particularly chest X-rays and pulmonary function tests, may indicate that an employee has been overexposed to asbestos, increasing his or her risk of developing exposure-related chronic diseases.
It is important for the physician to become familiar with the operating conditions in which occupational exposure to asbestos is likely to occur.
This is particularly important in evaluating medical and work histories and in conducting physical examinations. When an active employee has been identified as having been overexposed to asbestos, measures taken by the employer to eliminate or mitigate further exposure should also lower the risk of serious long-term consequences. The employer is required to institute a medical surveillance program for all employees who are or will be exposed to asbestos at or above the permissible exposure limit, 0.1 fiber per cubic centimeter of air. All examinations and procedures must be performed by or under the supervision of a licensed physician, at a reasonable time and place, and at no cost to the employee.
Although broad latitude is given to the physician in prescribing specific tests to be included in the medical surveillance program, OSHA requires inclusion of the following elements in the routine examination. I.
Medical and work histories with special emphasis directed to symptoms of the respiratory system, cardiovascular system, and digestive tract.
2. Completion of the respiratory disease questionnaire contained in Appendix D.
3. A physical examination including a chest X-ray and pulmonary function test that includes measurement of the employee's forced vital capacity, FVC, and forced expiratory volume at 1 second, FEV1.
4. Any laboratory or other test that the examining physician deems by sound medical practice to be necessary.
The employer is required to make the prescribed tests available at least annually to those employees covered,
more often than specified if recommended by the examining physician, and upon termination of employment. The employer is required to provide the physician with the following information: a copy of this standard and appendices,
a description of the employee's duties as they relate to asbestos exposure, the employee's representative level of exposure to asbestos, a description of any personal protective and respiratory equipment used, and information from previous medical examinations of the affected employee that is not otherwise available to the physician. Making this information available to the physician will aid in the evaluation of the employee's health in relation to assigned duties and fitness to wear personal protective equipment if required. The employer is required to obtain a written opinion from the examining physician containing the results of the medical examination, the physician's opinion as to whether the employee has any detected medical conditions that would place the employee at an increased risk of exposure-related disease, any recommended limitations on the employee or on the use of personal protective equipment, and a statement that the employee has been informed by the physician of the results of the medical examination and of any medical conditions related to asbestos exposure that require further explanation or treatment. This written opinion must not reveal specific findings or diagnoses unrelated to exposure to asbestos, and a copy of the opinion must be provided to the affected employee.
1910.1001 Appendix I. Smoking Cessation Program Information for Asbestos, Non-Mandatory.
Appendix I to Section 1910.1001.
Smoking Cessation Program Information for Asbestos, Non-Mandatory.
The following organizations provide smoking cessation information.
1.
The National Cancer Institute operates a toll-free cancer information service, CIS, with trained personnel to help you. Call 1-800-for-a-cancer* to reach the CIS office serving your area, or write Office of Cancer Communications, National Cancer Institute, National Institutes of Health, Building 31, Room 10A24, Bethesda, Maryland, 20892. 2. American Cancer Society, 3340 Peachtree Road, NE, Atlanta, Georgia, 30026, 404, 320-3333. The American Cancer Society, ACS, is a voluntary organization composed of 58 divisions and 3,100 local units. Through the Great American Smokeout in November, the annual Cancer Crusade in April, and numerous educational materials, ACS helps people learn about the health hazards of smoking and become successful ex-smokers.
3. American Heart Association, 7320 Greenville Avenue, Dallas, Texas, 75231-214, 750-5300.
The American Heart Association, AHA, is a voluntary organization with 130,000 members, physicians, scientists, and laypersons, in 55 state and regional groups. AHA produces a variety of publications and audiovisual materials about the effects of smoking on the heart. AHA also has developed a guidebook for incorporating a weight control component into smoking cessation programs. 4. American Lung Association, 1740 Broadway, New York, New York, 10019 212, 245-8000. A voluntary organization of 7,500 members, physicians, nurses, and laypersons, the American Lung Association, ALA, conducts numerous public information programs about the health effects of smoking. ALA has 59 state and 85 local units. The organization actively supports legislation and information campaigns for non-smokers' rights and provides help for smokers who want to quit, for example, through Freedom from Smoking, a self-help smoking cessation program. 5. Office on Smoking and Health, U.S. Department of Health and Human Services, 5600 Fishers Lane, Park Building, Room 110, Rockville, Maryland, 20857. The Office on Smoking and Health, OSHA, is the Department of Health and Human Services lead agency in smoking control. OSHA has sponsored distribution of publications on smoking-related topics, such as free flyers on relapse after initial quitting, helping a friend or family member quit smoking, the health hazards of smoking, and the effects of parental smoking on teenagers. In Hawaii, on Oahu, call 524-1234, call collect from neighboring islands. Spanish-speaking staff members are available during daytime hours to callers from the following areas: California, Florida, Georgia, Illinois, New Jersey, area code 201, New York, and Texas. Consult your local telephone directory for listings of local chapters. 1910.1001 Appendix J. Polarized light microscopy of asbestos. Non-mandatory. Appendix K to Section 1910.1001 Polarized light microscopy of asbestos. Non-mandatory. Method number ID 191. Matrix, bulk, collection procedure. Collect approximately 1 to 2 grams of each type of material and place into separate 20 ml scintillation vials. Analytical procedure. A portion of each separate phase is analyzed by gross examination, phase polar examination, and central stop dispersion microscopy. Commercial manufacturers and products mentioned in this method are for descriptive use only and do not constitute endorsements by OSHA. Similar products from other sources may be substituted. 1. Introduction. This method describes the collection and analysis of asbestos bulk materials by light microscopy techniques, including phase polar illumination and central stop dispersion microscopy. Some terms unique to asbestos analysis are defined below. Amphibole. A family of minerals whose crystals are formed by long, thin units which have 2 thin ribbons of double-chain silicate with a brucite ribbon in between. The shape of each unit is similar to an I-beam. Minerals important in asbestos analysis include cummingtonite grunerite, crocidolite, tremolite actinolite, and anthophyllite. Asbestos, a term for naturally occurring fibrous minerals. Asbestos includes chrysotile, cummingtonite grunerite asbestos, amosite, anthophyllite asbestos, tremolite asbestos, crocidolite, actinolite asbestos, and any of these minerals which have been chemically treated or altered. The precise chemical formulation of each species varies with the location from which it was mined. Nominal compositions are listed. Asbestos fiber, a fiber of asbestos meeting the criteria for a fiber. See Section 3.5 of this appendix. Aspect ratio, the ratio of the length of a fiber to its diameter, usually defined as length, width, e.g. 3:1. Brucite, a sheet mineral with the composition MgOH2. Central stop dispersion staining microscope. This is a dark field microscope technique that images particles using only light refracted by the particle, excluding light that travels through the particle unrefracted. This is usually accomplished with a Macron objective or other arrangement which places a circular stop with apparent aperture equal to the objective aperture in the backfocal plane of the microscope. Cleavage fragments. Mineral particles formed by the combination of minerals, especially those characterized by relatively parallel sides and moderate aspect ratio. Differential counting. The term applied to the practice of excluding certain kinds of fibers from a phase contrast asbestos count because they are not asbestos. Fiber. A particle longer than or equal to 5 m with a length to width ratio greater than or equal to 3:1. This may include cleavage fragments.
See section 3.5 of this appendix. Phase contrast.
Contrast obtained in the microscope by causing light scattered by small particles to destructively interfere with unscattered light, thereby enhancing the visibility of very small particles and particles with very low intrinsic contrast.
Phase contrast microscope.
A microscope configured with a phase mask pair to create phase contrast.
The technique which uses this is called phase contrast microscopy, PCM. Phase polar analysis.
This is the use of polarized light in a phase contrast microscope.
It is used to see the same size fibers that are visible in air filter analysis.
Although fibers finer than 1 m are visible, analysis of these is inferred from analysis of larger bundles that are usually present.
Phase polar microscope. The phase polar microscope is a phase contrast microscope which has an analyzer, a polarizer, a first-order red plate and a rotating phase condenser all in place so that the polarized light image is enhanced by phase contrast. Sealing encapsulant. This is a product which can be applied, preferably by spraying, onto an asbestos surface which will seal the surface so that fibers cannot be released. Serpentine.
A mineral family consisting of minerals with the general composition Mg3, C2O5, OH, for having the magnesium in brucite layer over a silicate layer.
Minerals important in asbestos analysis included in this family are chrysotile, lizardite, antigorite. 1.1.
History. Light microscopy has been used for well over 100 years for the determination of mineral species. This analysis is carried out using specialized polarizing microscopes as well as bright field microscopes.
The identification of minerals is an ongoing process, with many new minerals described each year.
The first recorded use of asbestos was in Finland about 2500 BC, where the material was used in the mud wattle for the wooden huts the people lived in as well as strengthening for pottery. Adverse health aspects of the mineral were noted nearly 2,000 years ago when Pliny the Younger wrote about the poor health of slaves in the asbestos mines. Although known to be injurious for centuries, the first modern references to its toxicity were by the British Labour Inspectorate when it banned asbestos dust from the workplace in 1898.
Asbestosis cases were described in the literature after the turn of the century.
Cancer was first suspected in the mid-1930s and a causal link to mesothelioma was made in 1965. Because of the public concern for worker and public safety with the use of this material, several different types of analysis were applied to the determination of asbestos content. Light microscopy requires a great deal of experience and craft.
Attempts were made to apply less subjective methods to the analysis.
X-ray diffraction was partially successful in determining the mineral types but was unable to separate out the fibrous portions from the non-fibrous portions. Also, the minimum detection limit for asbestos analysis by X-ray diffraction, XRD, is about 1%. Differential thermal analysis, DTA, was no more successful. These provide useful corroborating information when the presence of asbestos has been shown by microscopy. However, neither can determine the difference between fibrous and non-fibrous minerals when both habits are present. The same is true of infrared absorption, IR. When electron microscopy was applied to asbestos analysis, hundreds of fibers were discovered present too small to be visible in any light microscope. There are two different types of electron microscope used for asbestos analysis: scanning electron microscope, SEM, and transmission electron microscope, TM. Scanning electron microscopy is useful in identifying minerals. The SEM can provide two of the three pieces of information required to identify fibers by electron microscopy: morphology and chemistry.
The third is structure as determined by selected area electron diffraction, SAED, which is performed in the TEM.
Although the resolution of the SEM is sufficient for very fine fibers to be seen, accuracy of chemical analysis that can be performed on the fibers varies with fiber diameter in fibers of less than 0.2 m diameter. The TEM is a powerful tool to identify fibers too small to be resolved by light microscopy and should be used in conjunction with this method when necessary. The TEM can provide all three pieces of information required for fiber identification. Most fibers thicker than 1 m can adequately be defined in the light microscope. The light microscope remains as the best instrument for the determination of mineral type.
This is because the minerals under investigation were first described analytically with the light microscope.
It is inexpensive and gives positive identification for most samples analyzed.
Further, when optical techniques are inadequate, there is ample indication that alternative techniques should be used for complete identification of the sample. 1.2. Principal minerals consist of atoms that may be arranged in random order or in a regular arrangement. Amorphous materials have atoms in random order, while crystalline materials have long-range order. Many materials are transparent to light, at least for small particles or for thin sections. The properties of these materials can be investigated by the effect that the material has on light passing through it. The 6 asbestos minerals are all crystalline with particular properties that have been identified and catalogued. These 6 minerals are anisotropic. They have a regular array of atoms, but the arrangement is not the same in all directions. Each major direction of the crystal presents a different regularity. Light photons traveling in each of these main directions will encounter different electrical neighborhoods, affecting the path and time of travel.
The techniques outlined in this method use the fact that light traveling through fibers or crystals in different directions will behave differently, but predictably. The behavior of the light as it travels through a crystal can be measured and compared with known or determined values to identify the mineral species. Usually, polarized light microscopy (PLM) is performed with strain-free objectives on a brightfield microscope platform. This would limit the resolution of the microscope to about 0.4 m.
Because OSHA requires the counting and identification of fibers visible in phase contrast, the phase contrast platform is used to visualize the fibers with the polarizing elements added into the light path. Polarized light methods cannot identify fibers finer than about 1 m in diameter even though they are visible.
The finest fibers are usually identified by inference from the presence of larger, identifiable fiber bundles. When fibers are present, but not identifiable by light microscopy, use either SEM or TEM to determine the fiber identity.
1.3.
Advantages and disadvantages. The advantages of light microscopy are: A. Basic identification of the materials was first performed by light microscopy and gross analysis. This provides a large base of published information against which to check analysis and analytical technique.
B. The analysis is specific to fibers.
The minerals present can exist in asbestiform, fibrous, prismatic, or massive varieties all at the same time. Therefore, bulk methods of analysis such as X-ray diffraction, IR analysis, DTA, etc., are inappropriate where the material is not known to be fibrous.
C. The analysis is quick, requires little preparation time, and can be performed on-site if a suitably equipped microscope is available.
The disadvantages are:
A. Even using phase-polar illumination, not all the fibers present may be seen. This is a problem for very low asbestos concentrations where agglomerations or large bundles of fibers may not be present to allow identification by inference. B. The method requires a great degree of sophistication on the part of the microscopist.
An analyst is only as useful as his mental catalog of images. Therefore, a microscopist's accuracy is enhanced by experience. The mineralogical training of the analyst is very important. It is the basis on which subjective decisions are made. C. The method uses only a tiny amount of material for analysis. This may lead to sampling bias and false results, high or low. This is especially true if the sample is severely inhomogeneous. D. Fibers may be bound in a matrix and not distinguishable as fibers, so identification cannot be made.
1.4. Method performance. 1.4.1.
This method can be used for determination of asbestos content from 0 to 100% asbestos. The detection limit has not been adequately determined, although for selected samples, the limit is very low, depending on the number of particles examined. For mostly homogeneous, finely divided samples, with no difficult fibrous interferences, the detection limit is below 1%.
For inhomogeneous samples, most samples, the detection limit remains undefined. NIST has conducted proficiency testing of laboratories on a national scale. Although each round is reported statistically with an average, control limits, etc., the results indicate a difficulty in establishing precision, especially in the low concentration range.
It is suspected that there is significant bias in the low range, especially near 1%. EPA tried to remedy this by requiring a mandatory point counting scheme for samples less than 10%. The point counting procedure is tedious and may introduce significant biases of its own. It has not been incorporated into this method. 1.4.2. The precision and accuracy of the quantitation tests performed in this method are unknown. Concentrations are easier to determine in commercial products where asbestos was deliberately added because the amount is usually more than a few percent. An analyst's results can be calibrated against the known amounts added by the manufacturer. For geological samples, the degree of homogeneity affects the precision. 1.4.3. The performance of the method is analyst dependent. The analyst must choose carefully and not necessarily randomly the portions for analysis to assure that detection of asbestos occurs when it is present. For this reason, the analyst must have adequate training in sample preparation and experience in the location and identification of asbestos in samples. This is usually accomplished through substantial on-the-job training as well as formal education in mineralogy and microscopy. 1.5. Interferences. Any material which is long, thin, and small enough to be viewed under the microscope can be considered an interference for asbestos. There are literally hundreds of interferences in workplaces. The techniques described in this method are normally sufficient to eliminate the interferences. An analyst's success in eliminating the interferences depends on proper training. Asbestos minerals belong to two mineral families, the serpentines and the amphiboles. In the serpentine family, the only common fibrous mineral is chrysotile. Occasionally, the mineral antigorite occurs in a fibril habit with morphology similar to the amphiboles. Amphibole minerals consist of a score of different minerals of which only 5 are regulated by federal standard: amosite, crocidolite, anthophyllite asbestos, tremolite asbestos, and actinolite asbestos. These are the only amphibole minerals that have been commercially exploited for their fibrous properties. However, the rest can and do occur occasionally in asbestiform habit. In addition to the related mineral interferences, other minerals common in building material may present a problem for some microscopists: gypsum, anhydrite, brucite, quartz fibers, talc fibers or ribbons, wollastonite, perlite, attapulgite, etc. Other fibrous materials commonly present in workplaces are fiberglass, mineral wool, ceramic wool, refractory ceramic fibers, Kevlar, Nomex, synthetic fibers, graphite or carbon fibers, cellulose, paper or wood, fibers, metal fibers, etc. Matrix embedding material can sometimes be a negative interference. The analyst may not be able to easily extract the fibers from the matrix in order to use the method. Where possible, remove the matrix before the analysis, taking careful note of the loss of weight. Some common matrix materials are vinyl, rubber, tar, paint, plant fiber, cement, and epoxy. A further negative interference is that the asbestos fibers themselves may be either too small to be seen in phase contrast microscopy, PCM, or of a very low fibrous quality, having the appearance of plant fibers. The analyst's ability to deal with these materials increases with experience. 1.6. Uses and occupational exposure. Asbestos is ubiquitous in the environment. More than 40% of the land area of the United States is composed of minerals which may contain asbestos. Fortunately, the actual formation of great amounts of asbestos is relatively rare. Nonetheless, there are locations in which environmental exposure can be severe, such as in the Serpentine Hills of California. There are thousands of uses for asbestos in industry and the home. Asbestos abatement workers are the most current segment of the population to have occupational exposure to great amounts of asbestos. If the material is undisturbed, there is no exposure. Exposure occurs when the asbestos-containing material is abraded or otherwise disturbed during maintenance operations or some other activity. Approximately 95% of the asbestos in place in the United States is chrysotile. Amosite and crocidolite make up nearly all the difference. Tremolite and anthophyllite make up a very small percentage. Tremolite is found in extremely small amounts in certain chrysotile deposits. Actinolite exposure is probably greatest from environmental sources, but has been identified in vermiculite-containing, sprayed on insulating materials which may have been certified as asbestos-free.
1.7. Physical and chemical properties. The nominal chemical compositions for the asbestos minerals were given in Section 1.
Compared to cleavage fragments of the same minerals, asbestiform fibers possess a high tensile strength along the fiber axis. They are chemically inert, non-combustible, and heat-resistant. Except for chrysotile, they are insoluble in hydrochloric acid, HCl. Chrysotile is slightly soluble in HCl. Asbestos has high electrical resistance and good sound-absorbing characteristics. It can be woven into cables, fabrics or other textiles, or matted into papers, felts, and mats. 1.8. Toxicology. This section is for information only and should not be taken as OSHA policy. Possible physiologic results of respiratory exposure to asbestos are mesothelioma of the pleura or peritoneum, interstitial fibrosis, asbestosis, pneumoconiosis, or respiratory cancer. The possible consequences of asbestos exposure are detailed in the NIOSH criteria document or in the OSHA Asbestos Standards 29 CFR 1910.1001 and 29 CFR 1926.1101 and 29 CFR 1915.1001. 2. Sampling procedure. 2.1. Equipment for sampling. A. Tube or cork borer sampling device. B. Knife. C. 20 ml scintillation vial or similar vial. D. Sealing encapsulant. 2.2. Safety precautions. Asbestos is a known carcinogen. Take care when sampling. While in an asbestos-containing atmosphere, a properly selected and fit-tested respirator should be worn. Take samples in a manner to cause the least amount of dust. Follow these general guidelines. A. Do not make unnecessary dust. B. Take only a small amount, 1 to 2 g. C. Tightly close the sample container. D. Use encapsulant to seal the spot where the sample was taken, if necessary. 2.3. Sampling procedure. Samples of any suspect material should be taken from an inconspicuous place. Where the material is to remain, seal the sampling wound with an encapsulant to eliminate the potential for exposure from the sample site. Microscopy requires only a few milligrams of material. The amount that will fill a 20 ml scintillation vial is more than adequate. Be sure to collect samples from all layers and phases of material. If possible, make separate samples of each different phase of the material. This will aid in determining the actual hazard. Do not use envelopes, plastic, or paper bags of any kind to collect samples. The use of plastic bags presents a contamination hazard to laboratory personnel and to other samples. When these containers are opened, a bellows effect blows fibers out of the container onto everything, including the person opening the container. If a cork borer type sampler is available, push the tube through the material all the way, so that all layers of material are sampled. Some samplers are intended to be disposable. These should be capped and sent to the laboratory. If a non-disposable cork borer is used, empty the contents into a scintillation vial and send to the laboratory. Vigorously and completely clean the cork borer between samples. 2.4. Shipment. Samples packed in glass vials must not touch or they might break in shipment. A. Seal the samples with a sample seal over the end to guard against tampering and to identify the sample. B. Package the bulk samples in separate packages from the air samples. They may cross-contaminate each other and will invalidate the results of the air samples. C. Include identifying paperwork with the samples, but not in contact with the suspected asbestos. D. To maintain sample accountability, ship the samples by certified mail, overnight express, or hand carry them to the laboratory. 3. Analysis. The analysis of asbestos samples can be divided into two major parts: sample preparation and microscopy. Because of the different asbestos uses that may be encountered by the analyst, each sample may need different preparation steps. The choices are outlined below. There are several different tests that are performed to identify the asbestos species and determine the percentage. They will be explained below. 3.1. Safety. A. Do not create unnecessary dust.
Handle the samples in HEPA filter-equipped hoods. If samples are received in bags, envelopes, or other inappropriate container, open them only in a hood having a face velocity at or greater than 100 fpm. Transfer a small amount to a scintillation vial and only handle the smaller amount. B. Open samples in a hood, never in the open lab area. C. Index of refraction oils can be toxic. Take care not to get this material on the skin. Wash immediately with soap and water if this happens. D. Samples that have been heated in the muffle furnace or the drying oven may be hot. Handle them with tongs until they are cool enough to handle. E. Some of the solvents used, such as THF, tetrahydrofuran, are toxic and should only be handled in an appropriate fume hood and according to instructions given in the safety data sheet. 3.2. Equipment. A. Phase contrast microscope with 10x, 16x, and 40x objectives, 10x Whitefield eyepieces, G22 Walton Beckett Graticule, Whipple disc, polarizer, analyzer, and first-order red or gypsum plate, 100-watt illuminator, rotating position condenser with oversized phase rings, central stop dispersion objective, Kohler illumination, and a rotating mechanical stage. B. Stereo microscope with reflected light illumination, transmitted light illumination, polarizer, analyzer, and first-order red or gypsum plate, and rotating stage. C. Negative pressure hood for the stereo microscope. D. Muffle furnace capable of 600 degrees Celsius. E. Drying oven capable of 50 to 150 degrees Celsius. F. Aluminum specimen pans. G. Tongs for handling samples in the furnace. H. High dispersion index of refraction oils, special for dispersion staining. N equals 1.550, N equals 1.585, N equals 1.590, N equals 1.605, N equals 1.620, N equals 1.670, N equals 1.680, N equals 1.690. I. A set of index of refraction oils from about N equals 1.350 to N equals 2.000 in N equals 0.005 increments. Standard for Beckline analysis. J. Glass slides with painted or frosted ends 1 by 3 inches 1 mm thick, pre-cleaned. K. Cover slips 22 by 22 mm, number 1/1/2. L. Paper clips or dissection needles. M. Hand grinder. N. Scalpel with both number 10 and number 11 blades. O. 0.1 molar HCl. P. Decalcifying solution, Baxter Scientific Products, ethylenediamine tetrashic acid, tetrasodium 0.7 g/L, sodium potassium tartrate 8.0 mg per liter, hydrochloric acid 99.2 g/liter, sodium tartrate 0.14 g/liter. Q. Tetrahydrofuran, THF, R. Hot plate capable of 60 degrees Celsius. S. Balance. T. Hacksaw blade. U. Ruby mortar and pestle. 3.3. Sample pre-preparation. Sample preparation begins with pre-preparation, which may include chemical reduction of the matrix, heating the sample to dryness, or heating in the muffle furnace. The end result is a sample which has been reduced to a powder that is sufficiently fine to fit under the cover slip. Analyze different phases of samples separately, e.g., tile and the tile mastic should be analyzed separately as the mastic may contain asbestos while the tile may not. A. Wet samples. Samples with a high water content will not give the proper dispersion colors and must be dried prior to sample mounting. Remove the lid of the scintillation vial, place the bottle in the drying oven and heat at 100 degrees Celsius to dryness, usually about 2H. Samples which are not submitted to the lab in glass must be removed and placed in glass vials or aluminum weighing pans before placing them in the drying oven. B. Samples with organic interference, muffle furnace. These may include samples with tar as a matrix, vinyl asbestos tile, or any other organic that can be reduced by heating. Remove the sample from the vial and weigh in a balance to determine the weight of the submitted portion. Place the sample in a muffle furnace at 500 degrees Celsius for 1 to 2H or until all obvious organic material has been removed. Retrieve, cool and weigh again to determine the weight loss on ignition. This is necessary to determine the asbestos content of the submitted sample, because the analyst will be looking at a reduced sample.
Note, heating above 600 degrees Celsius will cause the sample to undergo a structural change which, given sufficient time, will convert the chrysotile to forsterite. Heating even at lower temperatures for 1 to 2H may have a measurable effect on the optical properties of the minerals. If the analyst is unsure of what to expect, a sample of standard asbestos should be heated to the same temperature for the same length of time so that it can be examined for the proper interpretation.
C. Samples with organic interference, THF.
Vinyl asbestos tile is the most common material treated with this solvent, although substances containing tar will sometimes yield to this treatment. Select a portion of the material and then grind it up if possible.
Weigh the sample and place it in a test tube. Add sufficient THF to dissolve the organic matrix. This is usually about 4 to 5 milliliters. Remember, THF is highly flammable.
Filter the remaining material through a tiered silver membrane, dry and weigh to determine how much is left after the solvent extraction. Further process the sample to remove carbonate or mount directly.
D.
Samples with carbonate interference. Carbonate material is often found on fibers and sometimes must be removed in order to perform dispersion microscopy.
Weigh out a portion of the material and place it in a test tube.
Add a sufficient amount of 0.1 mHCl or decalcifying solution in the tube to react all the carbonate as evidenced by gas formation, i.e., when the gas bubbles stop,
add a little more solution. If no more gas forms, the reaction is complete.
Filter the material out through a tiered silver membrane, dry and weigh to determine the weight lost.
3.4. Sample preparation. Samples must be prepared so that accurate determination can be made of the asbestos type and amount present.
The following steps are carried out in the low-flow hood. A low-flow hood has less than 50 ppm flow.
1.
If the sample has large lumps, is hard, or cannot be made to lie under a cover slip, the grain size must be reduced. Place a small amount between two slides and grind the material between them or grind a small amount in a clean mortar and pestle. The choice of whether to use an alumina, ruby, or diamond mortar depends on the hardness of the material.
Impact damage can alter the asbestos mineral if too much mechanical shock occurs.
Freezer mills can completely destroy the observable crystallinity of asbestos and should not be used. For some samples, a portion of material can be shaved off with a scalpel, ground off with a hand grinder or hacksaw blade. The preparation tools should either be disposable or cleaned thoroughly. Use vigorous scrubbing to loosen the fibers during the washing. Rinse the implements with copious amounts of water and air dry in a dust-free environment. 2. If the sample is powder or has been reduced as in 1 above, it is ready to mount. Place a glass slide on a piece of optical tissue and write the identification on the painted or frosted end. Place 2 drops of index of refraction medium N equals 1.550 on the slide. The medium N equals 1.550 is chosen because it is the matching index for chrysotile.
Dip the end of a clean paper clip or dissecting needle into the droplet of refraction medium on the slide to moisten it. Then dip the probe into the powder sample.
Transfer what sticks on the probe to the slide. The material on the end of the probe should have a diameter of about 3 mm for a good mount.
If the material is very fine, less sample may be appropriate.
For non-powder samples such as fiber mats, forceps should be used to transfer a small amount of material to the slide. Stir the material in the medium on the slide, spreading it out and making the preparation as uniform as possible. Place a cover slip on the preparation by gently lowering onto the slide and allowing it to fall trapdoor fashion on the preparation to push out any bubbles. Press gently on the cover slip to even out the distribution of particulate on the slide. If there is insufficient mounting oil on the slide, 1 or 2 drops may be placed near the edge of the cover slip on the slide.
Capillary action will draw the necessary amount of liquid into the preparation. Remove excess oil with the point of a laboratory wiper. Treat at least 2 different areas of each phase in this fashion. Choose representative areas of the sample.
It may be useful to select particular areas or fibers for analysis.
This is useful to identify asbestos in severely inhomogeneous samples.
When it is determined that amphiboles may be present, repeat the above process using the appropriate high dispersion oils until an identification is made or all 6 asbestos minerals have been ruled out. Note that percent determination must be done in the index medium 1.550 because amphiboles tend to disappear in their matching mediums.
3.5. Analytical procedure. Note, this method presumes some knowledge of mineralogy and optical petrography. The analysis consists of 3 parts: the determination of whether there is asbestos present, what type is present, and the determination of how much is present. The general flow of the analysis is 1. Gross examination. 2.
Examination under polarized light on the stereo microscope.
3. Examination by phase polar illumination on the compound phase microscope. 4. Determination of species by dispersion stain.
Examination by Beckline analysis may also be used, however, this is usually more cumbersome for asbestos determination. 5. Difficult samples may need to be analyzed by SEM or TEM, or the results from those techniques combined with light microscopy for a definitive identification. Identification of a particle as asbestos requires that it be asbestiform. Description of particles should follow the suggestion of Campbell.
Figure 1.
For the purpose of regulation, the mineral must be one of the 6 minerals covered and must be in the asbestos growth habit. Large specimen samples of asbestos generally have the gross appearance of wood.
Fibers are easily parted from it. Asbestos fibers are very long compared with their widths.
The fibers have a very high tensile strength as demonstrated by bending without breaking. Asbestos fibers exist in bundles that are easily parted, show longitudinal fine structure, and may be tufted at the ends, showing bundle of sticks morphology. In the microscope, some of these properties may not be observable.
Amphiboles do not always show striations along their length even when they are asbestos. Neither will they always show tufting.
They generally do not show a curved nature except for very long fibers. Asbestos and asbestiform minerals are usually characterized in groups by extremely high aspect ratios, greater than 100:1. While aspect ratio analysis is useful for characterizing populations of fibers, it cannot be used to identify individual fibers of intermediate to short aspect ratio. Observation of many fibers is often necessary to determine whether a sample consists of cleavage fragments or of asbestos fibers. Most cleavage fragments of the asbestos minerals are easily distinguishable from true asbestos fibers. This is because true cleavage fragments usually have larger diameters than 1 m. Internal structure of particles larger than this usually shows them to have no internal fibrillar structure. In addition, cleavage fragments of the monoclinic amphiboles show inclined extinction under crossed polars with no compensator. Asbestos fibers usually show extinction at 0 degrees or ambiguous extinction if any at all. Morphologically, the larger cleavage fragments are obvious by their blunt or stepped ends showing prismatic habit. Also, they tend to be acicular rather than filiform. Where the particles are less than 1 m in diameter and have an aspect ratio greater than or equal to 3:1, it is recommended that the sample be analyzed by SEM or TEM if there is any question whether the fibers are cleavage fragments or asbestiform particles. Care must be taken when analyzing by electron microscopy because the interferences are different from those in light microscopy and may structurally be very similar to asbestos.
The classic interference is between anthophyllite and biopyrrole or intermediate fiber.
Use the same morphological clues for electron microscopy as are used for light microscopy, e.g. fibril splitting, internal longitudinal striation, fraying, curvature, etc.
1. Gross examination.
Examine the sample, preferably in the glass vial.
Determine the presence of any obvious fibrous component.
Estimate a percentage based on previous experience and current observation.
Determine whether any pre-preparation is necessary.
Determine the number of phases present. This step may be carried out or augmented by observation at 6 to 40 times under a stereo microscope. 2. After performing any necessary pre-preparation, prepare slides of each phase as described above. 2 preparations of the same phase in the same index medium can be made side by side on the same glass for convenience. Examine with the polarizing stereo microscope. Estimate the percentage of asbestos based on the amount of birefringent fiber present. 3. Examine the slides on the phase polar microscopes at magnifications of 160 and 400 times. Note the morphology of the fibers. Long, thin, very straight fibers with little curvature are indicative of fibers from the amphibole family. Curved, wavy fibers are usually indicative of chrysotile. Estimate the percentage of asbestos on the phase polar microscope under conditions of crossed polars and a gypsum plate. Fibers smaller than 1.0 mm in thickness must be identified by inference to the presence of larger, identifiable fibers and morphology. If no larger fibers are visible, electron microscopy should be performed. At this point, only a tentative identification can be made. Full identification must be made with dispersion microscopy. Details of the tests are included in the appendices. 4. Once fibers have been determined to be present, they must be identified. Adjust the microscope for dispersion mode and observe the fibers. The microscope has a rotating stage, one polarizing element, and a system for generating dark-field dispersion microscopy. See section 4.6 of this appendix. Align a fiber with its length parallel to the polarizer and note the color of the Beck lines. Rotate the stage to bring the fiber length perpendicular to the polarizer and note the color. Repeat this process for every fiber or fiber bundle examined. The colors must be consistent with the colors generated by standard asbestos reference materials for a positive identification. In N equals 1.550, amphiboles will generally show a yellow to straw yellow color indicating that the fiber indices of refraction are higher than the liquid. If long, thin fibers are noted and the colors are yellow, prepare further slides as above and the suggested matching liquids listed below. Type of asbestos. Index of refraction. Chrysotile. Index of refraction is N equals 1.550. Amosite. Index of refraction is N equals 1.670 or 1.680. Chrysotile. Index of refraction is N equals 1.690. Anthophyllite. Index of refraction is N equals 1.605 and 1.620. Tremolite. Index of refraction is N equals 1.605 and 1.620. Actinolite. Index of refraction is N equals 1.620. Where more than one liquid is suggested, the first is preferred. However, in some cases this liquid will not give good dispersion color. Take care to avoid interferences in the other liquid, e.g., wollastonite in N equals 1.620 will give the same colors as tremolite. In N equals 1.605 wollastonite will appear yellow in all directions. Wollastonite may be determined under crossed polars as it will change from blue to yellow as it is rotated along its fiber axis by tapping on the cover slip. Asbestos minerals will not change in this way. Determination of the angle of extinction may, when present, aid in the determination of anthophyllite from tremolite. True asbestos fibers usually have 0 degrees extinction or ambiguous extinction, while cleavage fragments have more definite extinction. Continue analysis until both preparations have been examined and all present species of asbestos are identified. If there are no fibers present, or there is less than 0.1% present, end the analysis with the minimum number of slides, 2. 5. Some fibers have a coating on them which makes dispersion microscopy very difficult or impossible. Beckline analysis or electron microscopy may be performed in those cases. Determine the percentage by light microscopy. TEM analysis tends to overestimate the actual percentage present. 6. Percentage determination is an estimate of occluded area, tempered by gross observation. Gross observation information is used to make sure that the high magnification microscopy does not greatly over or underestimate the amount of fiber present. This part of the analysis requires a great deal of experience. Satisfactory models for asbestos content analysis have not yet been developed, although some models based on metallurgical grain size determination have found some utility. Estimation is more easily handled in situations where the grain size is visible at about 160 times or about the same and the sample is relatively homogeneous. View all of the area under the cover slip to make the percentage determination. View the fields while moving the stage, paying attention to the clumps of material.
These are not usually the best areas to perform dispersion microscopy because of the interference from other materials. But they are the areas most likely to represent the accurate percentage in the sample. Small amounts of asbestos require slower scanning and more frequent analysis of individual fields. Report the area occluded by asbestos as the concentration. This estimate does not generally take into consideration the difference in density of the different species present in the sample. For most samples, this is adequate. Simulation studies with similar materials must be carried out to apply microvisual estimation for that purpose and is beyond the scope of this procedure. 7. Where successive concentrations have been made by chemical or physical means, the amount reported is the percentage of the material in the as submitted or original state. The percentage determined by microscopy is multiplied by the fractions remaining after pre-preparation steps to give the percentage in the original sample. For example, Step 1. 60% remains after heating at 550 degrees Celsius for 1H. Step 2. 30% of the residue of Step 1 remains after dissolution of carbonate in 0.1 mHCl. Step 3. Microvisual estimation determines that 5% of the sample is chrysotile asbestos. The reported result is R equals microvisual result in percent times fraction remaining after step 2 times fraction remaining of original sample after step 1, R equals 5 times 0.30 times 0.60 equals 0.9%. 8. Report the percent and type of asbestos present. For samples where asbestos was identified, but is less than 1%, report asbestos present, less than 1%. There must have been at least 2 observed fibers or fiber bundles in the 2 preparations to be reported as present. For samples where asbestos was not seen, report as none detected. Auxiliary information. Because of the subjective nature of asbestos analysis, certain concepts and procedures need to be discussed in more depth. This information will help the analyst understand why some of the procedures are carried out the way they are. 4.1. Light. Light is electromagnetic energy. It travels from its source in packets called quanta. It is instructive to consider light as a plane wave. The light has a direction of travel. Perpendicular to this and mutually perpendicular to each other are 2 vector components. One is the magnetic vector and the other is the electric vector. We shall only be concerned with the electric vector. In this description, the interaction of the vector and the mineral will describe all the observable phenomena. From a light source such a microscope illuminator, light travels in all different directions from the filament. In any given direction away from the filament, the electric vector is perpendicular to the direction of travel of a light ray. While perpendicular, its orientation is random about the travel axis. If the electric vectors from all the light rays were lined up by passing the light through a filter that would only let light rays with electric vectors oriented in one direction pass, the light would then be polarized. Polarized light interacts with matter in the direction of the electric vector. This is the polarization direction. Using this property, it is possible to use polarized light to probe different materials and identify them by how they interact with light. The speed of light in a vacuum is a constant at about 2.99 by 108 meters per second. When light travels in different materials such as air, water, minerals or oil, it does not travel at this speed. It travels slower. This slowing is a function of both the material through which the light is traveling and the wavelength or frequency of the light. In general, the more dense the material, the slower the light travels. Also, generally, the higher the frequency, the slower the light will travel. The ratio of the speed of light in a vacuum to that in a material is called the index of refraction, n. It is usually measured at 589 nanometers, the sodium D line. If white light containing all the visible wavelengths, travels through a material, rays of longer wavelengths will travel faster than those of shorter wavelengths. This separation is called dispersion. Dispersion is used as an identifier of materials as described in section 4.6. 4.2. Material properties. Materials are either amorphous or crystalline. The difference between these 2 descriptions depends on the positions of the atoms in them. The atoms in amorphous materials are randomly arranged with no long-range order. An example of an amorphous material is glass. The atoms in crystalline materials, on the other hand, are in regular arrays and have long-range order. Most of the atoms can be found in highly predictable locations. Examples of crystalline material are salt, gold, and the asbestos minerals. It is beyond the scope of this method to describe the different types of crystalline materials that can be found, or the full description of the classes into which they can fall. However, some general crystallography is provided below to give a foundation to the procedures described. With the exception of anthophyllite, all the asbestos minerals belong to the monoclinic crystal type. The unit cell is the basic repeating unit of the crystal, and for monoclinic crystals can be described as having three unequal sides, two 90 degrees angles and one angle not equal to 90 degrees. The orthorhombic group, of which anthophyllite is a member, has three unequal sides and three 90 degrees angles. The unequal sides are a consequence of the complexity of fitting the different atoms into the unit cell. Although the atoms are in a regular array, that array is not symmetrical in all directions. There is long-range order in the three major directions of the crystal. However, the order is different in each of the three directions. This has the effect that the index of refraction is different in each of the three directions. Using polarized light, we can investigate the index of refraction in each of the directions and identify the mineral or material under investigation. The indices alpha, beta, and gamma are used to identify the lowest, middle, and highest index of refraction, respectively. The x direction, associated with alpha, is called the fast axis. Conversely, the z direction is associated with gamma and is the slow direction. Crocidolite has alpha along the fiber length, making it length-fast. The remainder of the asbestos minerals have the gamma axis along the fiber length. They are called length-slow. This orientation to fiber length is used to aid in the identification of asbestos. 4.3. Polarized light technique. Polarized light microscopy, as described in this section, uses the phase-polar microscope described in section 3.2. A phase contrast microscope is fitted with two polarizing elements, one below and one above the sample. The polarizers have their polarization directions at right angles to each other. Depending on the tests performed, there may be a compensator between these two polarizing elements. A compensator is a piece of mineral with known properties that compensates for some deficiency in the optical train. Light emergence. G from a polarizing element has its electric vector pointing in the polarization direction of the element. The light will not be subsequently transmitted through a second element set at a right angle to the first element. Unless the light is altered as it passes from one element to the other, there is no transmission of light. 4.4. Angle of extinction. Crystals which have different crystal regularity in two or three main directions are said to be anisotropic. They have a different index of refraction in each of the main directions. When such a crystal is inserted between the crossed polars, the field of view is no longer dark but shows the crystal in color. The color depends on the properties of the crystal. The light acts as if it travels through the crystal along the optical axis. If a crystal optical axis were lined up along one of the polarizing directions, either the polarizer or the analyzer, the light would appear to travel only in that direction, and it would blink out or go dark. The difference in degrees between the fiber direction and the angle at which it blinks out is called the angle of extinction. When this angle can be measured, it is useful in identifying the mineral. The procedure for measuring the angle of extinction is to first identify the polarization direction in the microscope. A commercial alignment slide can be used to establish the polarization directions or use anthophyllite or another suitable mineral. This mineral has a 0-degree angle of extinction and will go dark to extinction as it aligns with the polarization directions. When a fiber of anthophyllite has gone to extinction, align the eyepiece reticle or graticule with the fiber so that there is a visual cue as to the direction of polarization in the field of view. Tape or otherwise secure the eyepiece in this position so it will not shift. After the polarization direction has been identified in the field of view, move the particle of interest to the center of the field of view and align it with the polarization direction. For fibers, align the fiber along this direction. Note the angular reading of the rotating stage. Looking at the particle, rotate the stage until the fiber goes dark or blinks out. Again, note the reading of the stage. The difference in the first reading and the second is an angle of extinction. The angle measured may vary as the orientation of the fiber changes about its long axis. Tables of mineralogical data usually report the maximum angle of extinction.
Asbestos-forming minerals, when they exhibit an angle of extinction, usually do show an angle of extinction close to the reported maximum, or as appropriate depending on the substitution chemistry.
4.5. Crossed polars with compensator. When the optical axes of a crystal are not lined up along one of the polarizing directions, either the polarizer or the analyzer, part of the light travels along one axis and part travels along the other visible axis. This is characteristic of birefringent materials. The color depends on the difference of the two visible indices of refraction and the thickness of the crystal. The maximum difference available is the difference between the alpha and the gamma axes. This maximum difference is usually tabulated as the birefringence of the crystal. For this test, align the fiber at 45 degrees to the polarization directions in order to maximize the contribution to each of the optical axes. The colors seen are called retardation colors.
K arise from the recombination of light which has traveled through the two separate directions of the crystal. One of the rays is retarded behind the other since the light in that direction travels slower. On recombination, some of the colors which make up white light are enhanced by constructive interference and some are suppressed by destructive interference. The result is a color dependent on the difference between the indices and the thickness of the crystal. The proper colors, thicknesses, and retardations are shown on a Michel-Levy chart. The three items, retardation, thickness, and birefringence, are related by the following relationship: R equals T, N gamma minus N alpha. R equals retardation, T equals crystal thickness in M, and N alpha, gamma equals indices of refraction. Examination of the equation for asbestos minerals reveals that the visible colors for almost all common asbestos minerals and fiber sizes are shades of gray and black. The eye is relatively poor at discriminating different shades of gray.
It is very good at discriminating different colors.
In order to compensate for the low retardation, a compensator is added to the light train between the polarization elements.
The compensator used for this test is a gypsum plate of known thickness and birefringence.
Such a compensator, when oriented at 45 degrees to the polarizer direction, provides a retardation of 530 nanometers of the 530 nanometers wavelength color. This enhances the red color and gives the background a characteristic red to red magenta color. If this full-wave compensator is in place when the asbestos preparation is inserted into the light train, the colors seen on the fibers are quite different. Gypsum, like asbestos, has a fast axis and a slow axis. When a fiber is aligned with its fast axis in the same direction as the fast axis of the gypsum plate, the ray vibrating in the slow direction is retarded by both the asbestos and the gypsum. This results in a higher retardation than would be present for either of the two minerals. The color seen is a second-order blue. When the fiber is rotated 90 degrees using the rotating stage, the slow direction of the fiber is now aligned with the fast direction of the gypsum and the fast direction of the fiber is aligned with the slow direction of the gypsum. Thus, one ray vibrates faster in the fast direction of the gypsum and slower in the slow direction of the fiber. The other ray will vibrate slower in the slow direction of the gypsum and faster in the fast direction of the fiber. In this case, the effect is subtractive and the color seen is a first-order yellow. As long as the fiber thickness does not add appreciably to the color, the same basic colors will be seen for all asbestos types except crocidolite. In crocidolite the colors will be weaker, maybe in the opposite directions, and will be altered by the blue absorption color natural to crocidolite. Hundreds of other materials will give the same colors as asbestos, and therefore, this test is not definitive for asbestos. The test is useful in discriminating against fiberglass or other amorphous fibers such as some synthetic fibers. Certain synthetic fibers will show retardation colors different than asbestos, however, there are some forms of polyethylene and aramid which will show morphology and retardation colors similar to asbestos minerals. This test must be supplemented with a positive identification test when birefringent fibers are present which cannot be excluded by morphology. This test is relatively ineffective for use on fibers less than 1 m in diameter.
For positive confirmation, TEM or SEM should be used if no larger bundles or fibers are visible. 4.6. Dispersion staining. Dispersion microscopy or dispersion staining is the method of choice for the identification of asbestos in bulk materials. Backline analysis is used by some laboratories and yields the same results as does dispersion staining for asbestos and can be used in lieu of dispersion staining. Dispersion staining is performed on the same platform as the phase polar analysis with the analyzer and compensator removed. One polarizing element remains to define the direction of the light so that the different indices of refraction of the fibers may be separately determined. Dispersion microscopy is a dark field technique when used for asbestos. Particles are imaged with scattered light. Light which is unscattered is blocked from reaching the eye either by the backfield image mask in a Macron objective or a backfield image mask in the phase condenser. The most convenient method is to use the rotating phase condenser to move an oversized phase ring into place. The ideal size for this ring is for the central disc to be just larger than the objective entry aperture as viewed in the back focal plane. The larger the disc, the less scattered light reaches the eye. This will have the effect of diminishing the intensity of dispersion color and will shift the actual color seen. The colors seen vary even on microscopes from the same manufacturer. This is due to the different bands of wavelength exclusion by different mask sizes. The mask may either reside in the condenser or in the objective back focal plane. It is imperative that the analyst determine by experimentation with asbestos standards what the appropriate colors should be for each asbestos type. The colors depend also on the temperature of the preparation and the exact chemistry of the asbestos. Therefore, some slight differences from the standards should be allowed. This is not a serious problem for commercial asbestos uses. This technique is used for identification of the indices of refraction for fibers by recognition of color. There is no direct numerical readout of the index of refraction. Correlation of color to actual index of refraction is possible by referral to published conversion tables. This is not necessary for the analysis of asbestos. Recognition of appropriate colors along with the proper morphology are deemed sufficient to identify the commercial asbestos minerals. Other techniques including SAM, TEM, and XRD may be required to provide additional information in order to identify other types of asbestos. Make a preparation in the suspected matching high dispersion oil, e.g., N equals 1.550 for chrysotile. Perform the preliminary tests to determine whether the fibers are birefringent or not. Take note of the morphological character. Wavy fibers are indicative of chrysotile while long, straight, thin, frayed fibers are indicative of amphibole asbestos. This can aid in the selection of the appropriate matching oil. The microscope is set up and the polarization direction is noted as in section 4.4. Align a fiber with the polarization direction. Note the color. This is the color parallel to the polarizer. Then rotate the fiber, rotating the stage 90 degrees so that the polarization direction is across the fiber. This is the perpendicular position. Again, note the color. Both colors must be consistent with standard asbestos minerals in the correct direction for a positive identification of asbestos. If only one of the colors is correct while the other is not, the identification is not positive. If the colors in both directions are bluish-white, the analyst has chosen a matching index oil which is higher than the correct matching oil, e.g. The analyst has used N equals 1.620 where chrysotile is present. The next lower oil, section 3.5, should be used to prepare another specimen. If the color in both directions is yellow-white to straw yellow-white, this indicates that the index of the oil is lower than the index of the fiber, e.g. The preparation is in N equals 1.550 while anthophyllite is present. Select the next higher oil, section 3.5, and prepare another slide. Continue in this fashion until a positive identification of all asbestos species present has been made or all possible asbestos species have been ruled out by negative results in this test. Certain plant fibers can have similar dispersion colors as asbestos. Take care to note and evaluate the morphology of the fibers or remove the plant fibers in pre-preparation.
Coating material on the fibers such as carbonate or vinyl may destroy the dispersion color.
Usually, there will be some outcropping of fiber which will show the color sufficient for identification. When this is not the case, treat the sample as described in section 3.3. And then perform dispersion staining.
Some samples will yield to Beckline analysis if they are coated, or electron microscopy can be used for identification.
5. References. 5.1.
Crane, D. Asbestos in Air, OSHA Method ID 160, revised November 1992.
5.2.
Ford, W. E., Dana's Textbook of Mineralogy, 4th ed., John Wiley & Son, New York, 1950, p.
7. 5.3.
Selikoff, I. J. Lee, D. H.K., Asbestos and Disease, Academic Press, New York, 1978, pages
320. 5.4. Women Inspectors of Factories. Annual Report for 1898, H.M. Statistical Office, London, p. 170, 1898. 5.5. Selikoff.
I. J. Lee, D. H.K., Asbestos and Disease, Academic Press, New York, 1978, pages
26, 30. 5.6.
Campbell, W. E. J., et al., Selected Silicate Minerals and Their Asbestiform Varieties, United States Department of the Interior, Bureau of Mines, Information Circular 8751, 1977.
5.7.
Asbestos, Code of Federal Regulations, 29 CFR 1910.1001 and 29 CFR 1926.58.
5.8.
National Emission Standards for Hazardous Air Pollutants, Asbestos NESHAP Revision, Federal Register, Volume 55, No.
224, November 20, 1990, p. 48410. 5.9. Ross, M.
The Asbestos Minerals, Definitions, Description, Modes of Formation, Physical and Chemical Properties and Health Risk to the Mining Community, Nation Bureau of Standards Special Publication, Washington, D.C., 1977.
5.10. Lilies are fibrous zeolites and endemic mesothelioma in Cappadocia, Turkey, J. OCC Medicine, 1981, 23, 8, 548, 550. 5.11. Occupational Exposure to Asbestos, 1972, U.S.
Department of Health Education and Welfare, Public Health Service, Center for Disease Control, National Institute for Occupational Safety and Health, HSM 72-10267.
5.12.
Campbell, W. E. J., et al., Relationship of Mineral Habit to Size Characteristics for Tremolite Fragments and Fibers, United States Department of the Interior, Bureau of Mines, Information Circular 8367, 1979.
5.13. Mefford, D.E. DCM Laboratory, Denver, Private Communication, July 1987. 5.14. Deere, W. A. Howie, Art A. Zussman, J. Rock Forming Minerals, Longman, Thetford, UK, 1974. 5.15. Kerr, P. F., Optical Mineralogy, 3rd ed. McGraw-Hill, New York, 1959. 5.16. Veblen, D.R. ed. Amphiboles and Other Hydrous Pyriboles, Mineralogy, Reviews in Mineralogy, Vol 9A, Michigan, 1982, pp 1-102. 5.17. Dixon, W. C. Applications of Optical Microscopy in the Analysis of Asbestos and Quartz, ACS Symposium Series, No. 120, Analytical Techniques in Occupational Health Chemistry, 1979. 5.18.
Polarized Light Microscopy, Macron Research Institute, Chicago, 1976.
5.19. Asbestos Identification, Macron Research Institute, G&G Printers, Chicago, 1987. 5.20.
Macron, W. C. Calculation of Refractive Indices from Dispersion Staining Data, The Microscope, No. 37, Chicago, 1989.
5.21. Levity, B. ed. Asbestos and Other Health-Related Silicates, ASTM Technical Publication 834, ASTM, Philadelphia, 1982. 5.22. Steele, E. and Wiley, A. Reardon, P.H. Ed. Mineralogical Characteristics of Asbestos, Geology of Asbestos Deposits, pages 93 to 101, SMEAME, 1981. 5.23.
Zussman, J., The Mineralogy of Asbestos, Asbestos, Properties, Applications and Hazards, pages 45 to 67. Wiley, 1979.